Discovery, go at throttle up. Discovery, go and throttle up. Discovery, go and throttle up.
in space, so you're trying to get to the MSC race. One man has all the clues to help you solve your blues. EJ is his name, and rockets are his game. Bolder than any man, crazy creations are his plan. Cities, Kerbal, and workers, they all are at his command. Oh God, that's all I can think of. Chat bothers him all day and night, but Eej always puts up a fight. Weird impressions, internet memes, EA is always so extreme. I'm not a good songwriter as you can. Turbo stuck in space, well, you're trying to get to the MSC race. One man has all the clues to help you solve your blues. EJ's his name, and rockets are his game. Bolder than any man, crazy creations are his plan. Cities, Kerbal, and workers, they all are at his command. I don't know if that's all I can think of. Chat bothers him all day and night, but Eej always puts up a fight. Weird impressions, internet memes, EA's always so extreme. I'm not a good songwriter as you can hear.
never taste the sweet. Science lessons learned in flight. Journey on through endless night. For the stars, we aim so high. The projected kiss goodbye. For science and carbon light, we'll keep flying through the light. Rocket launch with hope so grand. EJ's got the master plan. Thrusters burn to reach the moon. In his eye you see the tune. Orbit dreams won't be delayed. Lessons learned from missions made. Kerbal Kind will forge a path to the stars beyond this path. For the stars, we aim so high. The projected kiss goodbye. For science and carbon light, we'll keep flying through the light. Rocket launch with hope so grand. EJ's got the master plan. Thrusters burn to reach the moon. In his eye you see the tune.
What do you know from funny, you
Flying through the light.
guy? Wait for it. Okay. How's everybody doing? It's good to be back. This isn't the hotel room? Oh, hey, look. We're live from the Margaritaville Hotel. Oh! You know, we're 3 months in to this year, and I've almost spent a third of that in Texas. All right. All right. All right. Hey, look, we're still in Texas. Texas thanks you. You're welcome. In the winter, which is good. Yeah. Quick question. Are you SpaceX's bad luck charm? No, I'm their booster catching good luck charm, son. Baby shark. Left shark. Anyway, I'm their booster catching good luck charm. Just thought I'd let you know. The summer in Texas do be sweaty though. Yes, very sweaty. All right. It's a frozen picture and not a very high resolution one. What about this picture would be moving? Of course it's frozen. Yeah, we're ready. Oh, look at that. I touched the bed. Oh, yeah. Almost long enough to get an accent. Yeah. Yep. We will not stop documenting these cameras until we catch this dang ship. Now watch this drive. Yeah? How is it? Is it good? Good? Now watch this drive. Oh, geez, shouldn't you be home? Yeah. Urban, hey, thanks for the raid, man. Yeah, no, the phone works. It's just you got to jiggle the handle a little bit or something. Basically, you never actually left Boca. Also, if Flight 9 is successful and you aren't there, should we read into that? Sick bed. Thank you. Isn't that nice? How did EJ teleport to Texas? Oh, well, Snotty beams me. Hey, Snotty, beam me down. Yes, sir. Immediately, sir. Snotty beamed you twice last night. It was wonderful. Oh, that's good. Has Titan missed me? Yep. Sorry, Captain. Captain! I can't give it any more, Captain. If we give it any more, the whole thing will blow. He says to make your bed. I did. See? Ready? Ready? See? Look. Delaware. Hi. I'm in Delaware. Wait, no, we're in Texas. Say, want to go to Texas. Howdy, partners. Let's raise a rope bronco. Howdy, y'all. Anyway, forget it. Forget it. No more beaming. This time I'm going to walk. All right. Sorry about your Bruins being screwed. No, we won't talk about that. Anyway, why do you have the same office chair in Texas as back home? Because you're so fat. All right, anyway. Told you to never call me on this wall. This is an unlisted wall. All right, anyway. So, space news. There is plenty to talk about other than, you know, the Turks and Caicos getting a taste of the rainbow across the sky. Taste the rainbow.
Discovery.
Everest, 31-month resub. Thank you. Thank you. All right, so. Spicy rainbow. Yep. Taste the heavy metal. Taste the heavy metal. The heavy metal? It's probably not going to be in tune, but...
Discovery, go at throttle up.
Probably not going to be in tune. Close enough. Well, that didn't take long to derail space news. All right. Put the axe down. All right. So, there's a lot to talk about. Flight 7, Flight 8 did a Flight 7, but the booster did get caught. It was awesome. I've been down in Texas for 2 weeks with helping NSF with stuff. Rocket Guy had a resub at a hundo. EJ, tell me, what did I roll before the Starship launch? I wasn't able to stay up all the way night a couple days ago. What did you roll? Your ad time that you rolled? I have no idea, dude. Funny looking pooper scoopers. That's right. The pie guy. Yes. Yeah. There's a lot of different news. There's also bad news. I don't necessarily want to dwell too much on the bad news, but yeah. Do you think they'll end up scrapping S-35? No, on the contrary, Kate, I think they're going to fly it. I don't want to do this. I don't want to do this. Can we just say that NASA started laying off people and that's not great, and we can all kind of equally agree that that's not great, and then just move on? Can we do that? I don't really feel like talking about this too much. Yeah. So NASA started laying off people in a major kind of reorganization. In line with executive orders. I'm sure if you want to read more into that, you can. Please don't do it here. I don't want to talk about this stuff. I think everybody here on this stream can agree that people laying off people from NASA is not a good look. It wasn't a good look when the last guy did it. It's not a good look when this guy does it. You know what I mean? It's not great. That's not ideal. And yeah, we'll leave it at that. with that being said, it does look like it's a major reorganization, which could potentially be good in the long run. Potentially, but most likely, hard to say. Hard to say. Yeah. I think that's more bad than anything. It's not like public sector layoffs are not a good. That's not great. That means something is not going well. And once again, this isn't the first time it's happened in the last 4 years. If you catch my drift, it's not the first. This isn't the first time it happened. JPL laid off like 400 people 2 years, or not 2 years ago, a year ago. I can only hope that the current rounds of layoffs at NASA are for a strategic reorganization, and I can only hope that they will have a potentially positive repercussion, because at least these ones are done with the intention of reorganization. The last ones were not. So we'll see where that takes us. I don't want to talk any more about it, guys. I really don't. I don't. No. Will it affect SLS? I don't know. I guess that means he got confirmed. Nope. These layoffs are in line with executive orders. So they were carried out at the behest of the the interim associate administrator of NASA, on orders from the executive branch. I don't want to say any more. I really don't, guys. I don't want to get into this. I mean, it does, like I said, the only thing that I can hope is that these layoffs are in anticipation of a reorganization, which is kind of like what we talked about, what I kind of wanted. Remember, I said if you made me NASA administrator, I would go in there and fire a lot of people. Well, a lot of the layoffs are management. So read into that what you see, or what you'd see or don't see. I don't know. If you want to read more into that, you can. If you want to read less into that, please do. To be fair, we have been calling for a big change at NASA for a bit, and we talked about people being there for the sake of a paycheck. That's what I'm hoping, Rocket Guy. I'm hoping that this is cleaning up shop in anticipation of reorganization, rather than just cleaning up shop for the sake of cleaning up shop, which is what the last round of layoffs were. Either way, layoffs in the short term are not great. That's not a good thing. But it could be in anticipation of a better thing down the road, but we'll see. I really, really don't have anything else to say about it until Jared Isaacman does or doesn't get confirmed as a NASA administrator. There's still no word on that. It was supposed to happen in February. It's now March. So we'll see. Me too, Denny. Yep. Paul, you met Bill Nelson last week at a political event. He was super nice. Bill seems like good people. Yeah. In retrospect, I think Bill did the best with what he had. It's really tough when you don't really have I will say it's really tough when spaceflight isn't taken seriously as a national priority. That's the right way to say it. Indeed, he went to DC and I haven't heard a thing since. Yeah, that's what I'm afraid of. Yeah, we'll see. Apparently the hearing is next week. Just heard some chatter. All right. Well, that's good. Did you get all the crazy relativity news? I have it teed up. Yep. All right. So we'll get to the rest of space news and we'll go from there. Yeah, he's in line. Okay, worst. Cool. Yep. Given what we know from reporting from Lauren Grush, they are closing the Office of Technology, Policy, and Strategy. I'm not too confident that it's layoffs for the sake of cutting fat. Technology, Policy, and Strategy? Yeah, because the strategy has been atrocious over the last 30 years. Just saying, man. Do you have an update on IM2? It tipped over, Cold Tech. And from what I can tell, they broke a landing leg again. So, take for that what you will. I don't know, James, maybe. My leg! Yeah, it seems like it got him down, but I don't think that the leg breaking, personally, was for the same reasons that a leg broke before. I think it broke because it landed on a hill. I think it landed on a hillside, snapped the leg, and then tipped over. But who knows? IM3 needs a redesign and has to operate laying on its side. Worked for Slim, I guess. Oh, okay. In other news, this is an article coming from Space News by Jeff Faust. They dropped Cygnus. No, like physically dropped it. Yeah. IM2 landed in the worst possible orientation, pushing all the solar panels away from the sun. Yep. Yep. FedEx did. Potential damage to a Cygnus cargo spacecraft has led NASA to revise the manifest of an upcoming Cargo Dragon mission to the ISS. NASA said late March 5th that it was assessing potential mission impacts to the next Cygnus mission scheduled for June after workers found damage to the shipping container for the spacecraft's pressurized cargo module when it was transported to the launch site in Florida. Mission teams will inspect the module during the coming days to assess whether there is any damage and any associated impacts to schedule. They were not down with the Cygnus. Oh, sorry, I was just clearing my throat. At a March 7 briefing about the upcoming Crew 10 mission to the station, NASA officials said it was too soon yet to know if the issue would delay the launch of the mission. Designated NG-22 and currently scheduled for June, I expect that we'll have some follow-on discussions and assessments to determine if there's spacecraft damage or impacts to the overall mission schedule, said Dana Weigel, NASA ISS program manager at the briefing. Sorry, I had the cough drops. I was just clearing my throat. Sorry, we got to pull up the sultry sounds of Starbase Live here momentarily. Oh yeah. So my headset doesn't time out. Oh yeah. Oh yeah, look at that. Look at that nice level trailer. Oh yeah. Oh yeah, that's great. Nice and level. I actually did level it this time, I'm not even kidding. Actually leveled it. And I made sure it was level. The problem is that the one of the mast cameras is bent. The mast is bent to the side. That's why it doesn't appear level. The trailer is dead on balls accurate. Did you find your blue Bronco down there? No, but I could have. What caused it to bend? Don't know. I don't know. But Rocket Guy, we're going to need to look at a complete trailer refactoring here momentarily. All right, anyway, so Cygnus. The shipping container for our pressurized cargo module for the NG-22 resupply mission was damaged during a commercial shipping accident as it went to the launch site. We are inspecting the PCM to assess its condition and will ensure NASA is aware of any impact to the mission that is currently scheduled for launch in June. NG-22 was originally scheduled to launch in February, but was delayed by an avionics issue with the spacecraft that neither NASA nor Northrop Grumman had widely publicized. Ooh. Trailer looks spiffy. Thank you, Luca. Yeah. The potential for additional delays in NG-22 led NASA to revise the cargo manifest for the next Dragon cargo spacecraft to the ISS, SpaceX-32, and scheduled it for late April. NASA said it will remove some of the science experiments that were to go on the mission and instead fly food and other consumables. Huh. Real challenge was just in large movement. Yeah, don't screw with ISS logistics. It's planned months, years in advance. Like, they have resupply missions through the end of life of the program right now. Another change is a shortened handover between Crew 10 and the departing Crew 9 mission at the station. Crew 10 is scheduled to launch on March 12th. That's on Wednesday. Coverage will be here. And arrive at the station early March 13th. NASA is planning to have a Crew 9 undock from the station as soon as March 16th. Shorter than the typical handover of 5 or more days between missions. Wow, Crew 9's going to be down by the end of the week. Weigel said the shortened handover was designed to conserve consumables during that time when there are 11 people on the station. What that really does for us is opens up more undocking opportunities, so we have a chance to find a good weather opportunity for undock to minimize how long we have additional crew on board. So someone dropped the Cygnus capsule. They specifically dropped the PCM. The PCM is the silver part. Not this silver part. This silver part right here. This cylinder. It's a cylinder, chat. Okay? It's a cylinder. And we dropped it. And it got stuck in something. What did you get it stuck in? Nothing. It's just a cylinder. No, that's the pressurized cargo part. So Cygnus is basically just a service module with a pressurized component in the front. That's about it. It doesn't even have a docking system built into it. Basically, it just flies up near the ISS and they grab it with the arm. That's it. The PCM is this part, the paneled part here. That's 3 layers. That part is the part that got dropped. Yep. Engine and power connects to a big tube. Huh. Tube. They dropped the cylinder in the square hole. Yeah, so that's going to screw with ISS logistics just a little bit, but it seems like everything seems all right there. Like, it's going to move around some stuff, but yeah. So they didn't drop the ball. No, they dropped the Cygnus. Hey, you guys want to see something cool? Look at this. Ready? Next bit of space news. It doesn't dock. Yeah, and yet... Okay, hold up. Uncapping... Wait, so it doesn't dock? Does that mean they have to spacewalk to retrieve supplies? No. You misunderstand it, boy. No, it births differences. It births. So in spaceflight nomenclature, pardon me, I probably should have explained this, but now you gave me the in to do it. In spaceflight nomenclature, there's docking and then there's berthing. Now, what is berthing? What does that mean? No, not B-I-R-T-H. No, B-E-R-T-H. Berthing. Differences. What is the difference? Berthing a spacecraft to the ISS means it does dock, but it doesn't use onboard systems to dock. Berthing means the capsule gets near the space station, they reach out with the arm, they grab the thing, and then they use the arm to dock it to the space station. The arm is basically your docking system. That's the difference. Docking is what Dragon and Starliner do. They automatically dock to the space station. They can just go up there, hone in on the target, zip, zop, zoobity bop, dock to the space station and go. That's what you see with the Dragon capsule, the Dragon cargo capsule, the Dragon crew capsule, and Starliner as well. That's what those do. That's docking versus berthing. Soyuz docks. Progress docks. Cygnus does not. Cygnus berths. When Dream Chaser goes to fly... I have news on that, by the way. When Dream Chaser goes to fly, it will berth as well. Does that make sense, Badger? Why is the far left monitor off? Well, I came back and it was broken. My mission control was all screwed up this morning. Came in here, the cameras didn't work, my screens were all messed up. Berthing, things KSP doesn't teach. You can berth stuff in KSP with the 2 DLCs. You can do that. It is difficult. Yeah. Difficult to do that. You can. It's tough. Yeah, I've done it. I've done it with a robotic arm with no inverse kinematics coded into its operating systems. It's very difficult. Anyway. You can do it. You can make a robotic arm. We've done it. Fun fact, the CBM ports are larger than the docking ports, so they could fit larger pieces of cargo through them. Mm-hmm. Yeah, the common berthing mechanisms, the dimensions for the CBMs, Bill, were derived from the ISS rack. The entire space station, the USOS side of the space station, is built around the modular racks that they have inside, and being able to move those in and out of the berthing modules. Yep. Which is why Cygnus is still a vital piece of equipment for the station, so you can bring racks up and down. Yep. Mm-hmm. Well, just up now, not down so much. But yeah, good to know. Also, we do have an update. Yeah, here we go. This is an update from Jeff Faust from the SAT Show convention, or SAT Show meeting here. I'm not exactly sure what the satellite show is. I think it's a summit for satellite operations and stuff. One interesting note from a SAT Show panel this morning. Eric Daler of Sierra Space says the company is now targeting the end of summer for the first Dream Chaser mission. All right. Cool. Eric Berger right below that. Which summer? What a weenie. That's a weenie thing to say. Anyway. Could you show us? Just kidding. Please don't subject me to that, Dan. Really, what is taking so long on Dream Chaser? I don't know. It's at the Cape, as far as I can tell. Jim, it's there. I don't know what they're doing with it, but it's there. Final processing. Well, yeah, but what that entails, I don't really know. Anyway. While we're there talking about that SAT Show panel, SpaceX's Stephanie Bednarik says that on a SAT Show panel that the company is now targeting 170 launches this year. The company previously announced a goal of 180. That's Falcon 9 launches for SpaceX. One of which, just on a side note, we will be watching tonight. If we go over to Next Space Flight here, you can see... Oh, Shazbot. Oh, nice. They're right next to each other. We have 2 Falcon 9s on the docket for 11 o'clock tonight. That's 5 hours from now. So one of them is launching out of Slick 4 at Vandenberg. This is the Sphere-X and Punch missions. So Sphere-X is the spectrophotometer for the history of the universe. Epic of Reionization and ICE's Explorer mission will provide the first all-sky spectral survey. Over a 2-year planned mission, the Sphere-X Observatory will collect data on more than 300 million galaxies, along with more than 100 million stars in the Milky Way, in order to explore the origins of the universe. Sun-synchronous orbit. And then there's Punch. Punch is a NASA Small Explorer, SMEX, mission to better understand how the mass and energy of the solar corona, the mass and energy of the sun's corona become the solar wind that fills the solar system. Well, mass ejections. Nice. 4 suitcase-sized satellites will work to produce images of the entire inner solar system around the clock. Cool. 2 really good missions. A good heliophysics mission there, and a good universe observation mission. Yes. That's cool. Sweet. So that's later tonight. The stream will be going all the way to that. We'll do more space news here, and then we'll play more workers. And then we'll go right to the launches. And then right after that, from Slick 40, there's Starlink 12-21. Which is the Starlink payload. Diamondium! No, Diamondium! Farnsworth. Lundstrom! Alright, anyway. EJ also transported tomorrow, which means another LZ mission in a row for Vandy. The transporter mission is scheduled for Wednesday. Oh boy, wow, you're gonna get a lot of EJ streams this week. Transporter 13 is scheduled for Wednesday. I very much doubt that they can flip that pad around that quickly. But I would really love to be proven wrong. I know a good amount of people that work on the Vandenberg integration team, which is pretty rad. Did you see the relativity update videos? I have not, Psychove. I have them in the queue, though. See? 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 Actually, we already covered that. See? 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 Check this out. How's this for news? Look at that. This is coming from Tori Bruno. Tori Bruno is the CEO of United Launch Alliance. His company is providing the interim cryogenic propulsion stage for the Artemis missions. That is a Delta cryogenic second stage, a Delta 4 DCSS. Delta 4, Delta cryogenic second stage. That's what it stands for. It is derived from that and is the upper stage for the Artemis 2 mission. It was moved from the DOC, Delta Operations Center, to Complex 39 for integration and stacking preparations on the Artemis 2 stack, which is being built in the VAB right now. See, they didn't drop that tube. 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 3 RTLS Falcon 9 missions. Very nice. Did they say what caused the tip over of the booster? Yeah, we can cover that real quick. So while I was down in Texas, SpaceX did launch a Starlink mission using booster, what was it, 1086, I think, on its 5th flight. And the booster didn't survive. It made it all the way down to landing and then didn't make it down to landing. Here, I believe Jerry Pike has a picture of what we're looking for. Oh, no, here's NSF. Here's Space Coast Live. Yeah, you can see that it ran into some problems, like right in this area here. Not here or here so much, but like right here. There's a little bit of an issue. So what happened here? There was a fire at the bottom of the booster, and the fire unfortunately collected around the landing leg that is not there anymore. And that caused booster 1086 to fall over. It fell over about 2 minutes after it landed. You can tell it's not good because of how it looks. Yeah. Yeah, see, this part seems all right. This part seems fine. See, this part's good. Not here or here so much. But, like, this part's nice. But, yeah, there was a fire on this booster. And it, unfortunately, the fire that happened when they were landing melted one of the landing legs and it tipped over. On the Crew 10 conference, commercial crew, Bill Gerst admitted there's a lot of quality control issues with Falcon and Dragon. Yeah, that makes sense. Dude, do you see the scale that they're operating at? Yeah, I would expect this. In fact, I'm amazed it didn't happen sooner, Baron, to be 100% honest with you. I know what it seems like, guys. It seems like Falcon is having some reliability problems. But yeah, that's what happens when you try to launch it 150 times, like, consecutively every year. That's a lot. They launched 144 times last year. And they launched 96 times the year before that, which is absolutely insane. These are unheard of numbers, guys. No one has ever done this before. I'm actually, like I said, Baron, I'm frankly amazed they were able to scale this reliably. I'm amazed that they didn't have any more production problems until now. Can you believe that? They only really started running into bottlenecking and quality problems when they scaled above 130 launches a year. Now, don't get me wrong. Those problems need to be fixed. One of these problems includes their second stages not deorbiting correctly and falling down over populated areas. I don't know if you guys know, but I don't cover the Chinese space program because of that exact reason. Rockets that come down in areas where there's population are not called rockets. Those are called missiles, and we don't jive with that here. We don't do that here, okay? Now, don't get me wrong. I'm a fan of an AIM-9 as much as anybody else is. That's not an ICBM. It's an air-to-air missile. I understand that. I know my missiles pretty well. But that's not what we plan to do here. It's not cool when they do it, and it's not cool when SpaceX does it. Don't deorbit things over populated areas. How about we don't do that? How about we don't do that? That's probably a good idea, just not doing that. I mean, the Chinese ones are on purpose, though. Yeah, no doubt. Which is why you still see me cover SpaceX's casts, and you will never see me cover a Chinese cast here. I won't do it. I have very, very, very big problems with hurting people in the name of space exploration. That's not space exploration. That's missiles. Those are different. No, I haven't, RB. Other companies tried to scale and failed. ULA is a prime example. ULA is getting there, but yeah. But yeah, Baron, it's an important thing to understand. Vulcan does not have its NSSL certification, which is very telling after the last observation that was seen. But I like to watch the orbits, Sag. I remember about 6 years ago when you deleted a Scud launcher you made in KSP. That's right. Yep. So what caused the fire? Zombie, that's a good thing to talk about. So the Falcon 9 did. It's not a fire from a perturbing outside force. Zombie, when a all right. I have a bottle of water here. This water bottle has been sitting here since before I left for Texas, but you get the idea. See that little residual? There's always a little bit of residual water in these things. See that? Right? I drank this thing till it was empty. But there's always a little bit of water left. Rocket engines, when they shut off, have that. There's always a little bit of residual water, or not water. There's always a little bit of residual propellants, rocket fuel, liquid oxygen, in the lines and in the combustion chamber that when the engine shuts off, they stay there. And they just find their way out of the rocket engine. So, a good example would be how, like, the Merlin vacuum engine on Falcon 9, after every time they fire it, they purge it out with helium, right? To make sure that they get all of the propellants out, right? Now, up in space, you don't need to worry about it. It's not that big of a deal. But when you're down here, that residual propellant gets shot out of the bottom. I call it burping. Basically, the rocket engine burps a little bit. Because oftentimes, those propellants mix, and the engine is still hot. It ends up auto-combusting it, and it detonates out the bottom of the vehicle. The rocket engines basically burp sometimes when you shut them off. It really depends. Sometimes it happens, sometimes it doesn't. The imprecision of fire is why this happens. I know what people are going to say. What do you mean? Don't they just have a way to just not have that happen? Well, yes and no. No, not really. I mean, it's just a hard thing to control because fire is relatively imprecise. Like fire doesn't burn perfectly uniform, right? So what happened with this thing is if you go and watch the landing footage, some of that residual gets shot out of the engine and it pops right next to the landing leg. Yeah, that happens. SpaceX, this isn't the first time that SpaceX has had a problem with this, believe it or not. A lot of people have a really short memory. Cast your mind back to JCSat 16. The JCSat 16 booster got absolutely annihilated on landing. In fact, if I just Google JCSat 16 landing, there a picture pops up in image search here of the exact thing happening, the exact same problem. See that? Look where that fire is. It's at the base of the landing leg. Huh, that's weird. No, not like that. Here's what really happened. I swear if this is just a roundabout way of saying what I'm saying, Baron, I'm kicking you in the face in Minecraft. Like, kicking you in the face. Like, and don't think I can't do it either, right? Kick you right in the face in Minecraft. Anyway. So that does happen, but apparently there was a little bit more to it. So let's see. I'll kick you in the header tag. Roadhouse. Roadhouse. ADJ pulls a muscle. No, I'm fine. I'm fine. I'm fine. Roadhouse. Yes, in the face. All right, so what do we got here? So this is in that same press conference. Gerstenmaier says there was a fuel leak about 85 seconds into ascent, which sprayed into a hot component of the engine that vaporized and created a flammable environment. But at that point in the flight, there was no oxygen to interact with it, so it wasn't a problem in ascent. He said on landing, there was enough oxygen that came into the engine compartment and created the fire. He added that it blew out the barrel panel on the side of the rocket. Oh, damn. So it is like JCSat 16. Actually, it's more like JCSat 14. 14 had this problem. Back in the day. Seriously. JCSat 14 had this exact problem. A little bit of a different reason, but in that thing, Gerst said that there was enough oxygen that came into the engine compartment and created a fire. He added that it blew out the barrel panel. Yeah, JCSat 14 blew out its barrel panels back in the day. You're looking at this Falcon 9 and you're like, oh yeah, that thing looks just fine. And then you look at the bottom and realize that the engines are completely exposed because all of those barrel panels blew out. Now, this problem was slightly different. This problem was because the boots around the Merlin engines burned off. Yeah, there's a little like piece of cloth insulation, or it's not cloth, but it looks like cloth around the engines, and re-entry heating came in there, pressurized inside of this, and blew the barrel panels off. Now, what are these panels for? It's the hood for the rocket. Yeah, for Falcon 9. Yep. There's 8 panels. You can get at the E1 through E8 engines. You can get at all the side engines. You can open up the cover and have all the turbine machinery right in front of you. It's a hood, like a hood on a car. Like the engine is underneath it. Those barrel panels are designed to blow out. They are designed to blow out if pressurization happens. Unfortunately, this one blew out and blew right into the landing leg. Whoops. So, yeah, that's JCSat 14 and JCSat 16 both had barrel panel blowouts. I don't think it was because of LOX leaks, but it might have been. I don't know. But yeah, there's a lot of things that can happen. So this one turned out to not be residual fire, even though that does happen, and JCSat 14 cooked because of that residual fire, and it blew out the panels. Because I don't think people understand. That thing, that booster is like... JCSat 14 came about as close as you can possibly get to a booster rud without actually having a booster rud. The blowout valve panel? Yeah, there you go. Paulina Kalin took this picture. This is during processing, though. This isn't, these things didn't get blown out like on JCSat, though. Those things got completely blown off. But yeah, there's your processing. Note that it looks like one of these blew out, and it blew out right into the landing leg. This is part of the reason why Falcon 9 Block 5, like you see in this picture, the whole bottom of the booster is thermal protection system. See how the Block 5 boosters have, like, it's all dark down here? Because one of the changes between a Block 4 booster and a Block 5 booster is the thermal protection systems on the south end, particularly on the dance floor, on the business end of the vehicle. Very, very different. How do you know all this? It's a pretty impressive level of information. I've been covering this for a long time, dude. I've watched Falcon 9 grow from a little babby rocket all the way to what it is now, to the Chad tier vehicle that it is now. I'm not going to say I could work on one or know the ins and outs of like the whole vehicle, but
Discovery,
you know,
go
you
and
tend to
throttle
pick up stuff covering this for a decade plus, you know what I'm saying? Hey, it end all 40 or 38 month resub. Thank you. Also, I played a lot of Kerbal back in the day. I played a lot of KSP back in the day, homie. Not that that helps, but it does help a lot. Dude, I have like 15,000 hours in KSP. I'm not even kidding. Ooh, something cool is coming out of production site, or the build site. Or not the build site, the pads at Starbase. What is that? 1066. Guys, that truck's load indicating 1066. What is that? And it's a freaking airport or container tug. Green, oxygen. 15,000 hours is almost 2 years straight. Yep. But yeah, me, I know a lot about this stuff, dude, because I love rockets. Rockets are my favorite. 1066 compressed 1066 compressed nitrogen tigs. Here, let's just double check. Don't you have the reference chart on your wall by now? No. Green would be oxygen. Googling this is not giving me anything. I would recommend downloading the 2024 ERG on your phone. It's a super good book for identifying all things hazmat. Ooh. Don't mind if I do. I think green is nitrogen, non-flammable, so it would be nitrogen. What happened to the SLS gimbal click that was behind him? That GIF screwed up. I have to fix it. UN 1066 is a UN identification number for compressed nitrogen gas, which is non-flammable. It's a haz gas that can cause rapid suffocation. Yep. Okay. I don't know why it didn't come up, but yeah, he was load indicating 1066. Now, okay, just quick thing, real quick. See the diamonds? See the diamond right there that says 1066? You can always tell what a truck is pulling by the indicator. Now, what are the indicators for? Are they for you and me? No, but it's still cool to read them when you're driving. You can see what it's moving. The most common ones that you're likely to see are 1993, 1202, and 1201. Or 1203, 1202 and 1203, and 1993. That's fuel oil, gasoline, and diesel fuel. Those are the trucks you probably see the most if you live in the city. Now, if you live down at Starbase, you probably see 1977. A lot. 1977. What's the number for milk? You don't need to load indicate for milk. So 1202 is diesel fuel, 1203 is gasoline, 1993 is fuel oil. So if you live somewhere where it's cold and you see the fuel oil trucks going around, 1993. Down in Brownsville, there are liquid nitrogen. So that one's gaseous nitrogen. But they have liquid nitrogen trucks going to Starbase, they have liquid oxygen trucks going to Starbase, and they have methane. Are they not manufacturing methane on site? No, they truck it in right now. Now, why? Okay, just a quick thing, quick derail for space news. Why would you load indicate something? Load indications are there for hazmat. They're hazmat. So they're indicated. I mean, okay, I'll give you an example. I don't know if you guys know this. Gasoline, particularly the vapors from gasoline, really, really, really likes to catch on fire. I don't know if you knew that. So you load indicate if you're carrying hazmat. If you like trucking, you would load indicate it. The load indicator is there for firemen to see how they need to fight the fire, because a diesel fire is different than a fuel oil fire, which is different than a gasoline fire. Spraying water on it might not always fix the problem. If you have a truck that's crashed and it's indicating 1066, don't get near it, because nitrogen, while harmless, in a 100% nitrogen environment, if you breathe 100% nitrogen, you die. Weird, right? The reason why, nitrogen displaces oxygen. The interesting thing is that you're breathing 80% nitrogen right now, 20% oxygen. 80% is fine. 90% you can probably get away with. 100% you die. Yeah, weird, huh? If the trailer says 1099, call the IRS. I understand that joke. Yep. Yeah, helium is the same story. Yep. Methane. Yep. Those placards are there indicating hazardous materials, or hazmat for short. I always dude, one of my favorite things to do when I'm driving on the highways or I'm driving around is I look at a truck and I try to say, oh, what's that? I saw a truck, dude, coming in and out of the port of Brownsville is all kinds of stuff. I saw 1268. Petroleum distillates. Oh. Yeah. Interesting. If you drove through a cloud of it, would you get an engine? Would your engine get a boost? No, dead scum. Driving through a cloud of nitrogen would kill your engine instantly. Your engine would just shut off. Now I know what you're thinking. Okay, so how does nitrous work then? Well, nitrous oxide, the buttons from the Fast and the Furious movies that makes a car go, you know, VTech just kicked in, yo. Those don't add more nitrogen. They actually take away nitrogen for your engine. Now, why? How does that work? Okay, so the best way that I can say how nitrous works in a car, why it makes you go faster, is because you're not increasing the nitrogen content. You're decreasing it. You are adding the oxygen content. Our atmosphere, more or less, I understand this isn't an exact perfect calculation. Our atmosphere is like 80% nitrogen and 20% oxygen. Technically 79% nitrogen, 20% oxygen, and then 1% stuff you probably shouldn't be breathing. Right? That's like where greenhouse gases are, stuff, etc., right? A car that's naturally aspirated, wait, I'll show that later. A car that's naturally aspirated is pulling in 20% oxidizer, but 80% nitrogen, right? That's enough to make the motor do things, right? When you spray nitrous into a car, right? And keep in mind, you have to spray more fuel. If you deliver more oxidizer, you have to deliver more fuel or else your engine blows up, right? When you spray nitrous into a car, so what's nitrous oxide? N2O. 2 nitrogen, 1 oxygen. So now you're increasing your oxidizer to 33% instead of 20. And if you can deliver more fuel, more oxidizer and more fuel going into your car makes your car go faster. Yep. So driving through a cloud of nitrogen is not going to do you any good. Your engine will shut off. Nitrous oxide is actually increasing, it's taking away nitrogen and increasing the oxygen going into your engine. Now, okay, so why do we use nitrous then? What do you mean? Well, that oxygen stays nice and stable with the 2 nitrogen. That's chemistry. But yeah, it's more or less stable with 2 nitrogen and an oxygen. Yep. You definitely don't want to spray LOX into your engine. That would be very bad. One, you'd hydrolock it if you didn't freeze it to death, right? Remember, operating temperatures. Right? So, yeah. Nitrous is N2O2, if I call correctly. No. I don't think so. But yeah, so driving through a cloud of nitrogen isn't going to work. Sorry, I was reading chat. That's why if you mix gasoline with 50% H2O, you can get better gas mileage. Organic peroxides. Ooh, neat. Well, that's pretty neat. How neat is that? There's another way that is a little bit easier and reusable. Nitrous, you spray it once, you got to refill the tank. There is another way to get more oxidizer into your engine. use a Nagasaki Noisy Boy. Yeah. You just need a Raptor combustion chamber inside your engine. Yeah, sure, Yuri. Yeah, okay. LOX belongs on your bagel, not in your V8. Yeah. Liquid oxygen likes to make everything explode very nicely. Yep. When did you get this? Yes. I got it. I think I gave it to myself as a present for Christmas. Will that fit in your Civic? Actually, Storm, yeah, probably. It's a GT35 ripoff, so with a T4 flange on it. So yes, it will actually fit in the Civic. This might be a little big for a Civic, but you know, put it in the 59. Where's the wastegate? Wastegate wouldn't be on the turbine housing, dude. I've been meaning to ask for a while. SpaceX keeps the booster pressurized to avoid it from crumbling under its own weight. How does that work at the end of flight? Starship can stand up without being pressurized, LS. It just sags a little bit. It's better to keep it pressurized. Think about it like sitting with bad posture versus sitting with good posture. Not Falcon 9. Starship can actually sit with the tanks unpressurized, but with the tanks unpressurized, it slouches. But you can, it can do it. You just don't want to do it for very long. Pressure, it makes it stand up straight, so to speak, or sit up straight. Right? Does that make sense? Do you think less regulation is better for space programs? No. No, believe it or not. Do we know where the debris landed? Turks and Caicos. It landed basically in the ocean. I see. Thanks for the fast reply. I got you, LS. Tag me. I like keeping up with chat, dudes. Tag me. If you tag me in chat, I'll answer your question. That's what I do. Charlie Watts versus Phil Collins. Good reference, dude. So RB, where did I get this? I got this for Christmas. I bought it for Christmas. You can get max speed turbos off Amazon for $100. $100. $100 for a turbo. Can you believe that? It's Chinesium, dude. But whatever. Spins pretty good for Chinesium. Not bad. I mean, I wouldn't put this on an engine that I really care about, but hey, whatever. It's $100 for a turbo. Yeah, I mean, it's Chinesium, but whatever. Will Jared be confirmed by 420? I don't know. Big C, 35-month resub. Good thing you got it before the tariffs. The tariffs with China aren't too bad, but yeah, exactly. $100 for a turbo. It's a Temu turbo, dude. It's not bad. Like I will say, it's not bad. It's a Garrett GT35 rip off. It's not bad. Like that's pretty good. You know, if it was really good, you could sit here and just do this and it would just keep spinning for days. But then again, the turbo isn't lubricated either. This one needs to be lubricated. You need to have pressurized oil going in and lubricating the turbine, the rotating turbine assembly. Stop stroking your turbo. I will not stop doing that. Shaft. You know what? I'm not talking about this with you no more. Putting this in the other room. Talking about this. Don't ruin my explanations. Oh, just on a quick side note, guys, I got the lubrication kit for it. Yeah. Complete with lubrication flange. Yeah, and all the hardware. And fake AN fittings, which is pretty good. This was like $20. But a really nice braided steel line. You should always use lubricant with your turbos if required. Hey, nice flange. Where's the turbo encabulator? I put it back into the truck. Is this the turbo you use every time you sneeze? Yes. How'd you know? Oh, headset timed out. Turn on Starbase Live again. Slightly off-topic question. We know that one of the advantages of using full-flow engines is that two gases reach the combustion chamber, allowing for higher combustion efficiency. Doesn't the RD-180 or any oxygen-rich stage combustion engine do the same? Yeah. The oxygen-rich pre-burner gases mixes with the heated gaseous fuel from the regen channels. I find it crazy how the Soviets managed that in the 60s. Necessity breeds innovation, Lava. They couldn't manufacture F1 engines. That's the truth. So they had to find a way to make a smaller, more powerful engine. Oxygen-rich stage combustion was the way that worked. Hey, Space Pope. Hello. Was looking at a launch schedule and showing a Firefly launch from the Antares pad on Wallops in 2026. Is there enough in common for that? Yes. Don't ask me why I know that. Are starships pressurized at the factory? Wouldn't that be dangerous if the pressurization failed? Look, man, if it can't hold, cheeseburger, we're talking like maybe 2 to 3 bar, maybe. So like maybe 20 to 30 PSI at the tanks when it's not at like flight pressure, right? If Starship couldn't hold that, it couldn't hold it at flight pressure. Flight pressure is much higher than that. What is flight pressure? Yeah, wouldn't you like to know, weather boy? No, I don't know what it is. I really don't. Yeah, the other thing is that's right, Rocket Guy. Oxygen rich is not gas, it's liquid to gas. Meaning you're taking liquid fuel and spraying it into gaseous oxygen. Like what a car does. But then you're getting into adiabatic compression versus, not that. It gets a little complicated from there. Something like that, Ariel. Yep. So that could be legit then. We could see another company launch at Mars. Firefly has been pining for that in the books for a long time, John. Yeah. Historically speaking, the USSR had better material science than the US, but America had better flow mixture modeling. So back then, the two engine types, fuel-rich and oxidizer-rich performances were actually the same or near enough. Yeah, that's right. Main tank pressure inside a Starship fuel tanks is 8.5 bar. How the hell do you guys know that? How do you know that? You shouldn't know that. Damn it. How do you know that? The hell? It was so saddening to see it fail again? Why? How do you not? I did know that. Shut up. Well, I was supposed to know that. So, okay, now that we know, good question. If they're pressurizing them, basically the rest pressure inside of Starship is a lot lower than flight pressure. And if it can't hold rest pressure, it can't hold flight pressure. That's why don't get me wrong, you're still dealing with a pressurized structure, but it's not that bad. Some of us play War Thunder. What the hell does that have to do? That one took me a second. Okay. All right. That one took me a second. That was good. All right. I'll give that one to you. That was pretty funny. Okay. All right, we were just talking about Firefly. Speaking of that. Wait a minute, hold up. That reminded me of this picture. Hold up. Okay, John. All right. No, it didn't happen again. It's just... That meme is very funny, dude. See last, food for thoughts. Oh, I'm not hungry. Thank you. And someone in Steam launched it. Again? I really do not envy the SpaceX team, man. It's a complicated problem. It's hard to model the harmonic resonance, and it's near impossible to catch on the stand since the surrounding structure will dampen the vibrations. Having vacuum jacketed fuel lines adds another layer of complexity, since they're meant to handle external pressure, since the interior is in a vacuum, but it's not specifically designed to absorb or resist internal vibrations. You had Steam open? All right, yeah, no problem. Yeah, I mean, there's still a little bit more news with relativity and whatnot. I was kind of saving Starship for the end, guys. I mean, the conversation inevitably found its way there. So, Baron, I was thinking about this the other day, and here, we'll go to my perfectly leveled trailer cam. All right. I did, Lunprod, yeah. So with Starship, what are they going to do with Ship 35, Xanax? I think they'll fly it. I think they'll just fly it, and it'll probably fail. You can fall in a situation that the fuel line reacts to itself and might break itself apart at the joints in fuel sumps. Yeah. Okay, RE Starship. Hoppy. And trailer cam is over there. This is from North. So Flight 8 did launch on the 6th. It launched last week. It failed catastrophically. They did catch the booster again, which is awesome. That's amazing. I was there. I saw it. I have a video camera on me for my reaction. If you want to see that, I'll have it uploaded sometime this week. Flight 8 seemed to have the exact same problems that Flight 7 did. Now, we didn't hear anything from SpaceX. We didn't hear anything from them regarding Flight 8 other than the vehicle failed. But the way the ship failed indicates that there was another fire. There was another fire at the bottom of this thing, and it did in fact blow up from seemingly harmonic resonance. Now, obviously, like I said, we don't have official word. We don't have official word from SpaceX here, but give me one moment. I'm gonna load up the footage. Oh, real quick before we here, look at this footage before we get into ship analysis. I see it. Yeah, the nozzles wobble just a little bit. Bruh. See him? See him jiggle? Look at him jiggle! Commence the jiggling! I like the jiggling! Oh, commence the jiggling. This is slow-mo of the Flight 8 launch. How does that purple wire survive? Remember, most things with engineering are just on the absolute brink. Holy Nikes. Bro, I've seen this footage before. I don't care. That's so cool. Oh my goodness. Most things in engineering are just on the brink of surviving. That hose is like probably like 10 or 20 degrees away from just melting itself completely. Oh my goodness, did you see that? Dude, that's so good. Oh my goodness. Anyway, all right. Here, actually, Max, my buddy Max over at NSF had a video edited footage here of it in real time. Look, here it is in real time. Watch this. Watch how violent this is. Bro! Holy crap. Yeah, I noticed that, Rocket Guy. You see the lines start to get cooked at the very end? Yeah, it's a little burnt. Oh, yeah. Bro. I think so, Yuri. I think that they're going to have to figure it out. Mm-hmm. Dude, how sick is that footage? All right, anyway. So, Flight 8 did launch. Let me get over to SpaceX's footage here. The booster did get caught, and dudes, if you haven't seen it, it's some of the most righteous freaking footage ever. It's so good. Here, let's load up the whole cast here. Watch this. Yeah, Aqualex, they folded back real quick. So this is a replay from last week, guys. I just wanted to show you.
7, 6, 5, 4, 3, 2.
That camera that we just saw started rolling right around now. It's down there somewhere in the fire.
We got
Bro! Dude, that's so good. I love this thing, man. I don't care if it doesn't work right now. That's amazing. When this thing goes, it's gonna go. It's so freaking cool, dude. Dude, it's violent. That is violent. Roll program.
All right, we're a little over 40 seconds.
You think the drone survived?
Of the flight. We are seeing
Maybe.
33 out of 33 Raptor engines ignited. Boosters pushing us downrange over the Gulf. Next milestone coming up in just under 10 seconds is going to be max Q, that max aerodynamic pressure.
Yeah, you see that, Alex? The drone's like about to die, and they're like, nope, switch it. Dude, look at
Max Q.
Look at that thing go.
All right, so we're through max Q. That's the heaviest stresses it's kind of seeing on the way up. Wow.
They throttle them.
Pretty incredible.
I'm still recovering. That was
Dude,
amazing.
what a monster. Look at this damn
Beautiful
thing.
views
Oh,
of the
it's so
vehicle,
cool.
ascent.
I mean, I watched this thing fly. I watched it fly last week. I was there. I'm down there somewhere. But-
Downrange away from
Dude,
the launch tower.
what the hell? This thing exists.
Next thing coming up is hot staging. So we're going to look for 6 engines to ignite on ship while we're still
Why not have
past
Falcon 9
the
chase with a wingman camera view?
We'll see all but those 3 center engines shut
I
down.
mean, I'm
on
not going to
booster.
say no to that, Dark Roo. Now, this is a replay, pilot. This is a replay from last week. This is Flight 8. I'm going through, I'm kind of bringing people up to
We're hearing
speed just
the
in case you
initial
didn't
call.
see it. Everything
We
worked
are
great on
go
the first
for
stage.
boost to The
here.
Starship second stage engine.
Look at the
Booster
IR.
engine cut off.
Watch. Watch this.
Ship engine start.
So I noticed a couple of things. Look, the booster, super heavy. In the past on Flight 7, if this is Starship and this is super heavy, it detached by doing this. This time it went under. Look, so the top of the booster, or the business end of the booster is that way. The top of the booster is facing down. It actually staged downwards this time, interestingly enough. That Starship booster, dude, look at that thing. That is a 20-story building flying around in space.
Boost back burn startup.
Look, what the frick?
There we go.
Oh, that's so
Ship engine
cool.
6 Raptors ignited.
I can't get over it. It's so legit. I know I'm
Looks like we got
fanboying
11
hard.
of the
Frick me.
13
I
we
get it.
planned for
I like
that.
all
That's
rockets,
gonna
but
start
damn,
sending
that's cool. Look, there it goes. You can see it
We are
boosting
still
back.
for booster return, even with
Ah!
during that boost back, we can do a full duration one. But
Chamber pushes nominal.
looks like we got a ship, 6 engines heading into space, and then we got a booster hopefully on our way back to Starbase. How's everything going in Hawthorne, Chris?
Everything is looking good. The
Not even into rockets like that, and it's
crowd
raw.
eagerly
It's so
followed that
cool,
ascent,
dude.
And now watch
Watch a ship propel and slosh during hot staging. Wait, really? Hold on, let me back it up.
But
Chamber pushes nominal.
we're doing that.
Here at the launch tower. Coming up now on hot staging, the ship's engines will ignite while still attached to the Super Heavy booster, and also while Super Heavy booster will still be under power itself. The clamps holding the 2 stages together are going to release, and Starship second stage engines will
Booster engine
ignite.
cut off.
And F-15 did it, Archie, once if I'm remembering right.
Ship
Oh,
engine
yeah.
startup.
I saw it. Yeah, they had a little momentary
Stage separation.
slosh right there. Just a little bit, though. Did you see it? Go back. I saw it. Drake, where's my engine? Yeah.
There we go. Ship engines all 6.
It was just a
Raptors
little bit, Rocket
ignited.
Guy.
We're doing that boost
The
back
pressure,
burn.
the
Looks
trans.
like we got 11
What would
of
it
the
be to
13
measure
and
the
we
fuel
can-
load? It would be a transducer. It had a momentary interruption. I'm gonna go ahead and assume that that's prop slosh, but it could be anything. Could just been a break in the telemetry.
And for
Go for
that,
boost
so
return.
that's going to start sending
Oh,
the booster back. We are still go for booster return, even with 2 Raptors out during that boost back. We can do a full duration one. But
there seems to be something missing here. Oh, believe me, I know. I knew about that before that picture got leaked. Believe it or not, dudes.
Chamber pushes
So
nominal.
looks
they-
like we got
they
a
didn't
ship,
get
6
all the engines
heading
boosting
into
back,
space,
but-
and then we got a booster hopefully on our way back to Starbase. How's
Probably,
everything
Yuri.
going in
That's another
Hawthorne,
good
Chris?
theory. A theory that you have is that Starship 34 and 33 are mostly the same ship, and they just couldn't fix it. It was already built and did minor adjustments that didn't work. Yuri, that's exactly what happened. I am 100% sure of that. That's exactly what happened. Mitigations are probably going to be put as we get closer to whatever the final fix is. I agree with you. I think that's 100% right. I think that's a very astute way of looking at it. I'm also in this picture.
everything is looking good. The crowd eagerly followed that ascent, and now watching the booster coming back.
Yeah,
So as you
pilot,
can see
yeah,
on the left-hand
that's
side
true.
Of your screen here, that is ship
avionics
continuing,
power
and
and
that's a
function
great view of ship.
I want you guys to remember this view here for a second, particularly the engines, okay? You have 1, 2, 3 sea levels, then 1, 2 Raptors here, okay? Just remember this view. Also, there's South Padre Island. I'm in this picture, and I do like it.
Ship continuing.
Just remember this picture for later. I'll tell you why. Just take a picture. Just take a mental note of this. There's 5. You can see 5 engines in this picture. The other RVAC is down there somewhere. It's underneath the 3 sea levels. We can't see it. We can see 1, 2, 3, 4, and 5.
On
Okie dokie?
its way to space, they're looking.
Just remember
that's
this.
Inside the camera, inside the aft skirt, looking at the Raptor vacuum and the sea level engines. The sea level ones there in the center of your screen under our T+ clock. You can see our boost back burn. We're down to 3 engines on the boost back burn.
Also, that's Chris G doing the talking. He's NSF alumni, by the way. I know Chris G. Chris is cool.
And you
Doing
can
the
see
cast
ship
for
on the right-hand
SpaceX.
side of that telemetry with 6 engines lit, continuing its ascent to orbit, already over 100 kilometers in altitude. The booster 87 kilometers in altitude and continuing its trek right now.
Is that image of the missing RVAC actually real? It's real, Jack.
Back to the landing site and catch site. There's a
Back shutdown.
and we just heard a good call out for boost back shutdown. The next thing we should see on our screen is the
My calculations are correct. When this thing hits 2,000 kilometers an hour, you're gonna see some serious stuff.
we do not need it for the landing.
Hot
but on
staging ring
future
jettison.
iterations of the Super Heavy, that hot stage ring will be
Was Chris commentating over the last Starship flight?
incorporated into
That's
the
him
booster and
commentating
you
right
will
now,
get it
yeah.
back. But for today,
Once
you
again,
can
this is
see
a
it on the
replay,
right-hand
dudes, just
side
in
of your
case
screen
anybody's
there,
wondering.
just
This is a
separating
replay
off from the
of the
right-hand
flight
side of the
flight
booster.
8, which was
You can
last
also see the booster
last
doing its
Thursday. That was
liquid
March
oxygen
6th.
dump there, which is exactly what we would expect for it to do as the booster gets itself configured for the landing here.
Dude, the IR camera is money, Rocket Guy. It's so good. Like missing, not just turned off. You tell me, Yarg. Remember how I said in that other picture there should be 5 engines? There's not 5 engines in this picture, there's 3. Chris commentated on Flight 7. No, he commentated on a Falcon 9 launch. This was the first time he commentated Starship. That's right, Jack, you're correct. Sorry, I ate it. I got hungry. Damn it, man! It would have gotten into space if you didn't eat it. Congratulations on SpaceX deploying their first payload. That's messed up, dude. You asked for a case, we brought you
Now,
a case.
Meanwhile, Starship will continue to coast after it reaches orbit for about 40 minutes or so, up to an altitude of 214 kilometers.
Are you suggesting Starship tracked through time, not exploded?
But it's still got a ways to go there. Currently
Oh,
accepting
Andrew, the RUD was particularly violent. I'll talk more about that in a second. Let's watch the good stuff first. Where did that leaked picture come from? Care to explain? I will when we get to the ship RUD. I want to show you the good stuff now.
past 75
SpaceX figured out smart before you
land there in velocity, and just look at those great views of the booster coming
It's
back.
so messed up.
The Gulf coastline there just looks absolutely gorgeous.
Starship is on a nominal trajectory.
And there we hear nominal trajectories all around. And
Dude, the
Dan
IR.
Cade
Oh, that IR
minutes,
picture is money.
15 seconds here into the flight. Everything looking good for the Super Heavy and for Starship today. What's it like there at Starbase as we get ready to catch?
It was incredible, Chris.
Chilling down the
be able
engines?
To see the mock diamonds with my own eyes.
So they're chilling down the engines here for a relight. Dude, this is my favorite part. Super Heavy flies through its plume, and it looks like a ODST coming out of the sky. It is the cool... Dude. Oh, just watch. Just watch.
We have heard that we are go for the
Gopher.
the catch of the booster.
So they're thermally conditioning the engines. That's what those dumps are that you see.
Tracking cameras were able to see the hot stage separate and fly away. So coming up in just about 30 seconds, we're going to look for the landing burn. We're going to.
I will in a second, Yarg, when we get to the ship part. Just watch.
Engines.
Look at the re-entry heating. Oh, that's so cool. Oh, I didn't notice this. Look at the re-entry heating. Look at how it propagates. Rocket Guy, look at this, dude. Look. The re-entry heating propagates everywhere where the engine chill isn't happening.
About 30 seconds. We're going to look for the landing burn.
Look! Oh, that's so cool! Look! The engine chill is keeping that part of the booster cool. Bro! That's awesome!
Engines to turn on.
And then once the chill down stops, it burns too. Oh, that is so badass, man. Thermodynamics and stuff. Dude.
Eventually moding down to only 3 engines for that precision flight
Bruh.
tower.
Right now,
Bruh.
we're using its 4
There it goes through the plume.
to help guide itself through
Dude, these IR pictures are money. I hadn't seen these yet.
Precision landing at the launch site. Once again, we're going to ignite first the
Ah!
13 engines. We should see that coming up here momentarily.
Engines and startup.
This is going to come down to 3 engines as the booster slows. And we just heard the sonic boom. What an incredible sight to see the super heavy booster gliding down.
Gimbal maxing.
Arms.
Bro, come on! That's ridiculous! And look, the CO2 suppressor put the fire out immediately.
Wow. That will never get old.
That is the coolest freaking thing I've ever seen, dude. And I've seen this happen twice. It is so nuts, dude. The chopstick's turning immediately. Yeah, I wonder why they did that.
We saw 12 out of 13 light for that landing burn. Boosters.
Personally, guys, I think,
with that final precision burn on the
dude, it is. It is. A lot of people noticed that this thing came in from, it flew out over here. If you traced its track on the ground, Super Heavy came in over here and then turned at the last second to come in. Guys, you want my honest opinion? Remember what I was talking about headwind for the chopsticks? Look at which way the wind is blowing. It's blowing in the exact, well, actually, that would have been a tailwind. Or no. Yeah, that would have been a tailwind. That's super interesting.
For the tower catch, so caught. Meanwhile, keeping an eye on ship.
It came in from the exact angle that the wind is blowing from.
Yep, still got
interestingly enough.
Burning. Those are going to continue.
Huh. Interesting. My guess is to keep things from falling onto the big sprinkler. Yeah, the whole thing kind of moved to the left.
For about another minute until we'll
Anyway. So, right around here is where things start to get a little bad. So I'm noticing a couple of things with the ship. See that? That's bad. What do I always say about non-uniform heating on nozzles? See that? That's bad. See that? That's also bad. See that? Very bad. So why is this happening? It's very clear at this point in the flight that this thing is leaking. It's leaking fuel. You can see fire right here. See? The fire is kind of faint because there's not a lot of oxygen, but it is burning something because we see flames all up in here. Now, something is gone. You're getting insane nozzle burn through right here. Now, why is this nozzle burn through happening? Well, one, you have fire heating the outside of your engines. There's not supposed to be heat coming from the outside because it's a rocket engine. Heat's supposed to come from the inside. That's a real easy way to put that. Second part is that you're getting non-uniform heating because the engines aren't getting enough fuel. You're burning lean. Do you remember what we were talking about a little while ago, like an hour ago, about turbochargers and nitrous oxide? And what happens when stuff gets too much oxidizer and not enough fuel? Oxygen is not very good at... I was about to say it's not really good at absorbing heat, but that's not the right way to say it. I mean, yeah, I suppose you could put it that way. So basically, we're talking about fuel mixture here, okay? When fuel mixture is a ratio. Anytime you have a bipropellant engine, you have a rate of mixture between your liquid fuel and your liquid oxygen, right? There is an ideal amount per chemistry, like in this case, liquid methane to liquid oxygen, to get all of the liquid methane and all of the liquid oxygen to perfectly combine and not have a lot of byproduct. That's what happens. That's why Raptors have such clear flames, right? Because you're getting most of the liquid methane and liquid oxygen to combine together to atomize and then explode. Okay. The shuttle engine, for instance, very, 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 very efficient. Its flames are clear, very clear flames because all of the hydrogen is being burnt. Now with methane, you're not going to get a perfect burn because there's that pesky carbon atom in there, but that also is what makes methane a little bit more easy to manage, right? But anyway, that's a little bit of a digress there. Me digress something? Interesting. So, Starship at this moment in time has a fuel leak. How do we know it has a fuel leak? Flames. The flames are orange. Methane burns orange and kind of bluish, depending on the temperature. There's definitely orange and blue flames right there. Yeah. Why orange and blue-ish? Because methane is carbon and hydrogen. Hydrogen likes to burn orange. Carbon likes to burn yellow, but that's another story. See that? You have a fuel leak. Easily a fuel leak. There's a fire inside of Starship right now. Where that fire is, I don't know. Now, well, we could probably discuss it in a moment where it is, but so because the fuel is leaking out and spraying outside and causing a fire outside, these engines are getting fuel starved. So that means in your ratio of liquid fuel to oxidizer, right? You have stoichiometric in the center, which means a perfect combination, right? And then you have more in favor of fuel, which is called running rich, right? Then you have running lean, which is more in favor of oxidizer. Once again, running lean makes extremely hot temperatures. Basically, the motors are overheating. Your engines are overheating at this point. Yeah, your engines are overheating because you have a fuel leak. The fuel is leaking overboard, causing a fire inside of the engine bay, and the engines are getting starved of fuel, and they're running more lean than anything. That explains the non-uniform heating that you're getting here. Because they use fuel to cool the nozzles, and you're obviously not cooling a lot of the nozzle because there's not enough fuel to take the heat. Couple that with the convection that's happening in the bottom of the engine bay, and the outside of the nozzles now being heated additionally on top of running lean. All of that combines
Really cool
to make a very, very catastrophically bad failure here in a second. Just watch. You guys will be able to tell. If you don't, just watch real close. It might be a little on the subtle side.
For us, that's looking right down inside essentially the skirt area of ship.
Now, something's gone very wrong here. I can already tell you just by that last shot. Something has gone very wrong. How do I know? Watch the horizon of Earth relative to the ship. You're getting a slewing motion here. See the ship slightly going that way? That is indicative of differential thrust. And it's differential thrust that the computer doesn't know really what to do with. Okay? See that? You see it shift? Something's wrong here. See? So this is what's called an uncontrollable rate. Meaning something is perturbing the vehicle to get it to list lazily to the right relative to the vehicle in this particular scenario, and the computer can't compensate for it. How would the computer compensate for it? Well, it would move those sea-level Raptors around. But once again, your engines are running lean. When you run lean, you also, in the application of rocket engines, you do get a more efficient burn, but you also get lower thrust. Running lean makes you produce not as much thrust. And in this particular case, you're already starting to see the results of a nozzle loss of control here because of differential thrust. Basically, not all the engines can get all the fuel that they need. Some of them are running lean. Some of them are running leaner than others. And because of this, the vehicle's starting to move out of the way.
Where you can see a pretty good view of all 6 Raptors, especially.
So, watch. Watch over here. It's subtle. Watch what happens.
Those 3 inner ones,
oh.
One of which we're going to hopefully relight a little bit later. And we just saw some engines go out. It looks like we are losing attitude control of.
Spoiler alert, it wasn't subtle. The engine let go. It let go. It let go. you're heating up everything on that engine. Because the engine can't dissipate the heat correctly, heat starts building up in the whole thing via heat conduction. It melted something, and the engine separated from the vehicle. Either that, or an engine, it melted the fuel and oxidizer lines, and we had some type of detonation down here. My guess is that the aft end of this ship got way too hot. The bottom, the thrust bulkhead here, basically the engine mount got too hot. It started melting, and it basically liberated an engine or two.
A million shout outs to all of our.
The rumor is that only the vacuum nozzle fell off. Interesting. I missed it. Here, watch again. So here at 7:55, Starship is getting a slewing motion, indicating differential thrust on the engines. That's absolutely what's going on here. There's no other thing that could be. If you see a car going down the road with a flat tire, there's a puncture in the tire, and it's really unlikely that it's going to be anything else. Right?
These cameras possible.
You know, I know it's not rocket science, and how does this moron on Twitch know everything? Like, about how do you know what's going on here? Well, the pictures are a pretty good example.
Well, for us, that's looking right down.
I've seen it, Ariel. Yes.
Essentially, the skirt area.
Must be your wife driving. Oh shoot! Noobzor, 70-month resub. Thank you.
You can see a pretty good view of all 6 Raptors.
Yeah. So check this out. Look. At this point in time, we lose telemetry from 2 of the sea levels and a vacuum engine.
Especially those 3 inner ones.
And something, look, so you have a cascading failure here, all right? Cascading failure. How do I know? Well, you have a telemetry loss from 3 engines, and Starship is still relatively moving on an even keel, proving out that differential thrust thing. The engines basically absorbed too much heat, stuff started to melt. They melted right off the gimbal mounts. If I had to guess, either that or there was some kind of nozzle burn through that basically caused the engine to completely obliterate itself. Guys, rocket engines don't... The interesting thing about rocket engines is that it's very rare that you're going to get an engine that's kind of working, right? Like, we saw the engines kind of work here for a second, but once Starship started doing this, started listing lazily to the right, yeah, that's basically it. You're not coming back from that. And it didn't take long before the engines to fail completely, right? Last, please. I'm kind of in the middle of something, in the middle of the explanation. Don't the Raptors run fuel rich? No, they do not run fuel rich. They're a full flow stage combustion. They run, it's not that they run fuel rich. They run close to stoichiometric, and they use fuel to film cool the combustion chamber, the throat, and the nozzle. At combustion, though, it's not stoic, but it's close. Lava Eagles, sometimes, if I had to guess, it's probably slightly biased towards methane. So if that's what you mean by fuel rich, yeah, kind of, right? This guy knows some maneuvers. Yeah. You think they may add a firewall between the vacuum and sea level engine bells? I'll get more into that in a second, Archie. Looking forward to more time on the water flow and dam game. Good to think about complex flow structures for the space station. Ah, there you go, home planet. So you're saying you want more Timberborn. All right, I'll get you Timberborn on Wednesday, okay? The Raptors do run fuel rich. Yeah, I guess if you want to call it that. Yeah, sure. So, check this out. So once again, look, we have a loss of signal. We have loss of telemetry from 2 engines right there. But Starship is clearly accelerating at the same rate, meaning that the wire harnesses on these engines are completely burned off. Once again, indicating a huge fire in the engine bay.
One of which were...
And then something catastrophically fails after that.
Where you can see a pretty good view of all 6 Raptors.
Watch. So see, you have 3 engines out, but Starship is technically still running on an even keel. The computer may have tried to compensate with that single engine and start gimbaling it to try and compensate for the differential thrust, but then something right there at 8:06, something catastrophically goes wrong back there. Something blows up. Once again, my guess, if I had to guess, this Raptor vacuum quit completely. It quit. It's just too hot. It got too hot. It melted the engine from the inside out. When a rocket engine melts, guys, it's not like a slow failure. When the melt through starts happening, right, and you start to get complete loss of pressure in the nozzle, it blows up. Once again, rocket engines, when they fail quick. Now, getting to that point of failure does take some time. It's often a cascading failure like what we're seeing here. But yeah, that vacuum engine quit. Absolutely. It tried. It was given all it could. It tried. So look, you see a loss here. It starts to compensate, right, for that differential thrust, and then right there, that's it. It popped. The engine completely flew off. Now, some people say, it's just the nozzle. It's just the nozzle. It's just the nozzle. I doubt it. I think the engine's completely gone. What's the dead giveaway for that? Well, you're seeing atomized fuel come out the bottom here. See this? This is fuel and oxidizer that's coming out the bottom of the vehicle. That's what that is. See that?
A little bit later.
Yeah, that's not great. I think telemetry is ahead by a couple of seconds. So the engine loss is the explosion that we see. Now, Rocket Guy, something curious. Everybody's saying Raptor vacuum, and I'm inclined to agree because there's that picture of the vacuum engine being lost. Dude, can I see? Hold on a second, fellas. Can I see this again? I thought it was a Raptor vacuum up until this point. I want to look at something here.
Especially those three inner ones, one of which we're going to hopefully relight a little bit later. And we just saw some engine.
Huh. Baron, will you let me figure it out, please, for a change? For the love of Christ, please let me figure it out without saying, no, it was this. That's not fun. Can you stop doing that?
One of which we're going to hopefully relight a little bit later.
So, the interesting thing that I'm noticing here, dudes. I've seen it, Derek. I know. Guys, the interesting thing that I'm noticing is that Vector engine is still going. There's two of them still working. Now, what happened to this one? I'm not sure. I mean, we have enough time to rewatch this footage as much since Starship isn't flying till the summer. Shows how much you know. Anyway, moving on. So, obviously, you lose your last Raptor sea level here. You lose the Raptor sea level, you have a loss of control. This is a lock all day. Loss of control. These are the engines that they use to steer. Gone. Now, once again, there's that differential thrust coming back. We still got good telemetry from these engines. Couple of cool things to notice here, just in case people are telemetry watching nerds like me. Let me move over here and I want to show you something. Watch. So Starship's obviously doing flips, right? Watch the fuel and oxidizer lines.
It looks like we are losing attitude control of the ship.
Watch them. Oh, they're going up. This is a good example of being able to discern what the vehicle's doing from telemetry. Obviously, you're not making more fuel, so what's going on here? Starship is tumbling. It's tumbling end over end. Obviously, the quickest and easiest way to figure this out is to see that your speed is going up and down, because the Starship's engines are firing backwards, and then they're firing forwards, and then they're firing backwards, and then they're firing forwards. So your velocity is going to go up and going to go down and going to go up and going to go down and going to go up and going to go down. That's a good way of indicating a very, very high pitch or yaw rate, right? Which obviously is unwanted. but also the fuel lines, the remaining fuel and oxidizer in the tanks is sloshing back and forth. It's going up and going down and sloshing up and sloshing down and sloshing up and sloshing down. And it's pushing on the pressure transducers. It's crashing into the pressure transducers that are used to denote fuel load. So the fuel lines, it says that the fuel quantity is going up and going down and going up and going down and going up and going down. Propellant slosh is what's going on here. See, look. As it flips over, the fuel lines go up, and then when it flips back, the fuel quantities go down, and then it goes up, and then it goes down. Isn't that cool? Kind of neat. Now, going back to the failure here.
Getting video down from the ship, you can see we've lost several.
Now, okay, my next question here is what this camera angle. So this has been making the rounds, and I don't like showing it, but this has been making the rounds. Where is this camera mounted? So once again, there should be a Raptor vacuum engine here. Would that slosh also cause cavitation for the engines? Absolutely, Jam. Yeah, absolutely. And remember, when we were back in the day when we were talking about SN8 and SN9, that's a no-no. Can you A-B compare ship 33 and ship 34 time of failure? Space Pope, it's about a 20-second differential. I've already done that. Yeah, I did that before. It's 20 seconds. So 20 seconds with the exact same kind of catastrophic failure, resulting in a very high loss of control and flip over rates. It's the same problem. It's the same thing. Have you seen this theory? No, I haven't seen it, Milge. I'm making my own right now. SpaceX stole your negative thrust trick. Yeah, they did. See this for camera location. Yeah, that doesn't really help me. In terms of figuring out where that camera is. Like, if I was going to point, where would this camera be? So the question is, did they try to fix the issue or did they send it? I'll get more into that in a second, Pop, because I have my theories about that. How do you think the onboard systems didn't shut down the last two engines? Yum food, because any electronics that's going to valves to kind of command these engines to shut off have long since burned away. You guys are talking about the ECU killing, oh, why didn't they just shut off the engines? Why didn't they just shut off the engines? There's no way you can prove to me that any engine control and management systems on this thing is still working correctly with a fire inside of the engine bay. How the heck do you know that? Did you stick your head up in there when the thing was going off? No, I think that this thing couldn't shut itself off. That's very much what happened. It burned off any components that were in there a long time ago. Because look, there's a slew. This is what I'm telling you. This failure was set into motion well before it happened. See what I'm saying? That RVAC that is off is the one that's missing, if that helps. Okay.
Skirt area of ship,
okay.
Where you can see.
So that one would be the one that's in this picture. That's that guy. Now, so, okay, so where is this camera then? Let's just think about this for a moment. Where is the camera?
A pretty good view of all six.
So we get a telemetry loss from the RVAC. Note from the Flight 2 investigation. Okay, I will note that later. You're making it very difficult for me to form a cohesive thought. Actually, let me just go back over here real quick. Okay. This camera is right here. It's up here. It's at the top of the ship. It's on the top axis. All right, because I know Starship rolls 90 degrees when it launches. See it right there? See it roll? See the roll program? So that camera would be over here, indicating that frame bottom on the camera is facing north. And if we look at this picture, north is this way. You can see all the way up to freaking Corpus in this picture. It's all the way up there. So Mexico is over here. This is the Gulf. That's Texas, right? So this camera is up here. It's at the top. All right, so the RVAC that failed, this one right here with the huge non-uniform heating is the one that popped. Let's get to the good parts. So I want to look at this again real quick.
Area of ship where you can see a pretty good view of all 6 Raptors, especially those 3 inner ones, one of which we're going to hopefully relight.
Oh, that's interesting. Fellas. Okay, look. Remember what I just said? This is what I'm getting at. You remember what I just said about you have no idea what's going on down here? I am going to go out on a limb and say that's bad telemetry. You cannot trust what that thing says. Why? Well, look. This one says two of the sea level engines are out. One of them is still working. 2 vacuum engines are working. Pretty sure the pilot light went out on that 3rd engine. I think it money shifted, monkey. I think they money shifted that engine. All right. I don't think this telemetry is good telemetry. I think that you really can't trust anything that's going on down here because any sensors were burned off a long time ago. It's in fact, this right here is most likely the wires that carry the data connection to show that an engine is on, probably burning away, if I had to guess. Why? Well, once again, this leaked picture is very telling. The really, really sharp-eyed people will notice that a Raptor vacuum is gone. So from this camera angle, right, this vacuum that's missing, we know is that motor right there. See that guy? It's that one. But something quite interesting to take into account here. Look, it says that that engine is still firing. Like I said, the keen-eyed will notice that the Raptor vacuum is gone. The real keen-eyed will notice that a sea level engine is missing as well. There should be one right here. There's only 2. And it's very interesting because those 2 engines still look very on. You can tell because you're getting plume interaction there. See what I'm talking about? You're getting plume interaction between this Raptor, this Vector, the Vector that's down there, and the 2 sea level engines. You see what I mean? What's the green hue? The green hue is most likely the engines completely leaning out and burning them, basically melting themselves from the inside out. Yeah, that's pretty much what's going on here. So look, those engines are very much on. This telemetry is bad telemetry. I'm 90% sure. 90.33, repeating, of course. It says that engine is on. That engine's gone, physically removed from the vehicle, meaning that this telemetry can't be trusted. Like you after Taco Bell, yes. Yeah, the green hue is copper inside, the copper lining inside of the Raptor engine burning off completely. Yeah, copper with actually anything can burn with the right amount of oxidizer. You could use titanium as solid rocket fuel if you have the right concentration of oxidizer. A Dragon capsule tried to do that once and it blew up. On the test stand when nobody was inside. That's engine rich. Yeah, it's the lining from the copper burning. Copper burns very green. Yeah. So, once again,
Especially those 3
this
inner
failure right there, once again, it says that that engine is on. That engine's not exist. That engine doesn't exist. It's not attached from the vehicle. Or if it is, it just detached right there. And parts of it are flying out over the Turks and Caicos. IMO, they lost control on the engine throttle response since the flight termination system was safe. They couldn't do anything about the two Raptor engines still firing while the vehicle's spinning. They just kept firing and spinning until the fuel sumps started ingesting gaseous methane, and LOX caused cavitation inside the turbopumps, which subsequently led to a power head explosion. Yeah, for the cascading failure after this, sure. Yeah, that pretty much makes sense. If the Vector shut down controlled before the RUD, could they have still kept going? This thing was doomed, Erudite. It was doomed. The second they lit the engines, it was basically screwed. They could have stopped. If the thing shut down the engines, they could have stopped it. But where's that going to get you? That's going to get you out in the middle of the Atlantic Ocean. It's probably better to just have the vehicle break up and crash. It reminds me of the Flight 2 investigation. Leak in the aft section of the spacecraft that developed with the liquid oxygen vent initiated... What is that? Was initiated, resulting in a combustion event and subsequent fires that led to a loss of communication between the spacecraft's flight computers. Yeah, that's what I mean, dude. That telemetry is caca. It's caca. It's no good. That telemetry's junk. This telem is bad. You can't trust it, especially after failure. So oh, that slew is awful. So they knew what would happen upon launching. Chief, this is obviously not the outcome that they wanted. I think they tried to implement a mitigation. I think they tried to implement something that made this not as bad, and they managed to get 20 seconds further from whatever mitigation they had implemented. But
It's possible for us that's looking
clearly that mitigation was not good enough. You know how I can tell?
Where you can see a pretty good view of all 6 Raptors, especially those 3 inner ones.
See right there? That's how I can tell. That pop was the engine flying off the back of the vehicle. Yeah. You see that? You see that right there? That's not good. Yeah, that's... Metal shards? No. Chief, that's the engine deciding to not want to be not being attached to the vehicle anymore. Now, once again, fellas, I want to guys, you're missing a sea level. A sea level engine exploded too and flew off the back of the vehicle. You're missing 2 engines in this picture. There should be 5 total that we can see. You can only see 3. So, once again, Bill, take a look at this picture. Those 2 engines are on in this picture, and this was after this RUD right here, right? Your telemetry over here during the failure says that it lost this engine and those 2 down there. This telemetry can't be trusted. Now, I think we can pretty damn conclusively say that this RVAC was the first one to fail. It failed because it was running lean. It's not supposed to run lean. As Lava Eagle kind of said, or asked me a little bit earlier, and I kind of had to think about it for a second, Raptor engines do run lean. Or they run rich. They don't run lean. Running engines that are designed to run rich lean makes them explode. Hey, Golden Goose, 96-month resub. I just wanted to say thank you for bringing some warm weather back with you. It's appreciated. Yeah, no problem, dude. Ship 34 wanted to go around, yeah, go home. It was dizzy, yep. Why is there a sea level engine in a vacuum? What's the advantage? Those engines are used for steering. See, well, that's actually a super good question. These engines right here are used for steering the ship when it's up in space. and they're used for landing the ship when it comes down to land. Now, I know what the question is. Why don't they put vacuum nozzles on that? They can't fit them. That's the point. They can't fit them. Yeah. The Raptor engines have 15 degrees of thrust vector control, meaning you can move 15 degrees off of your main thrust vector. If you notice, the engine configuration here allows for the cluster of 3 to be able to move. They can move down like this, they can move up like that, or they can move up like that. They can move every engine 15 degrees. Now, don't get me wrong, there are some points where you can't gimbal these engines because there's a nozzle in the way, right? But this allows them to get good range of motion because they don't have the space down there. There's not enough real estate to put 6 vacuum engines in here. They also need the sea level engines for landing. Did I not say that, fellas? I could have sworn I just said that they use them for landing. I'm actually asking. I did? Okay, cool. Just want to make sure I'm not losing my mind. Because you guys are right. Yeah, they use them for landing too. Absolutely. That was not me giving you guys crap. That was making sure my brain isn't a fried egg. Okay? On that note, Raptors are shielded, so if it's a power head or combustion chamber failure, the detonation shield would have caught it. So that failing vacuum engine nozzle took out the other 2 sea level with it. That's the thing, dude. It didn't, though. That's what I'm trying to tell you. It absolutely didn't. This says that the RVAC that's missing in the picture is gone, and it said that those 2 engines failed, and one of them is still working. Yet in this picture right here, those 2 engines are still on. Baron, do you see what I'm trying to tell you? Those engines are still on. And 2 RVACs are still on in this, which is why I'm thinking this is bad telemetry. Do you see what I'm saying? This is bad telemetry because those 2 engines are still working, which indicates that the fire probably destroyed all the wiring to these engines, but somehow they're still working. No, Bill, the camera's up here. The engine camera, this camera is on top of Starship. It's the top of Starship. It's up here. It's indicating that this motor right here, this motor, that one is that motor right there. Does that make sense? Now, keep in mind, this camera is slightly shifted. So I'll take out the model. I'll show you guys the model. So look, this camera is offset. It's over here. It's like aligned on this vector right here. But it's more or less at the top, but it's not on the center line. It's over here. It's just slightly offset, which is why it gives the optical illusion that this is from the side, that the camera might be like over here or something. It's not. It's on the top. It's right here. Does that make sense? And in that regard, where the hell is that sea level engine that the telemetry said was still working? Guys, there's no doubt that that Raptor vacuum over here failed. And there's no doubt that it failed because it's running lean. You have hot spots all over your nozzle. That's no good. See that? That's a ticking time bomb, quite actually. Right? No doubt. What happened to that sea level engine? That's what I'm wondering. The sea level engine is gone too in this picture. Look, it's not there. It should be right there. It's not there. So then wouldn't the Raptor vacuum that detached be on the right side of the frame and not the left? No. Why would it? This camera is facing backwards, dude. This engine failing facing backwards is an engine on the left-hand side. What did you? You're talking about the see these? SVO? See the non-uniform hotspots? That's bad. That's really bad. Yeah, Mowgli, this telemetry is telemetry. These numbers are all telemetry driven, meaning it's pulling right from whatever SpaceX's telemetry API is. But This tells me that, I mean, it's wrong. The telemetry is wrong. Now, guys, once again, okay, so what am I getting at? What is EJ? What are you looking for, EJ? So what? It's no secret that engine failed. This engine failed miserably, but you also got hot spots on the other Raptors, interestingly enough. That engine failed. We know it failed. It failed catastrophically. How did it fail? The fuel leak from the fire that's happening right here. I don't know if you guys can see it. It's very faint. See the fire? That's a fuel line leak. So the engine is running lean, which explains the hot spots. That engine failed. Was the explosion generated from this failure enough to liberate an entire sea level engine? Because it's gone. That sea level engine is gone. It also liberated itself from the vehicle. Guys, I could be going out on a limb here. You guys call me nuts if you want. We know that SpaceX's telemetry is bad. And we know that Raptor vacuum failed. I guess what I'm getting at is it possible that the sea level engine failed before it? What if the sea level engine broke? What if it melted a gimbal and then, you know, like it melted one of the gimbal actuators and then binded itself and slammed into the Raptor vacuum and blew both of them completely off the Starship? Because so Baron, you actually pointed this out. The center engines on Starship are shielded. They are shielded inside of a metal shroud. Whatever explosion that happened was violent enough to blow a sea level engine completely out the back of the vehicle and a Raptor vacuum engine out the back of the vehicle. Does that make sense, dudes? What if it's hard to prove unless you see the complete video? Well, that's no fun. Belt, we're not getting the full thing. That's no fun. It's fun to kind of sit here and see if my judgment is correct. And it's entertaining for you, right? Obviously, we'll wait until we can't say anything conclusively. We wait until SpaceX tells us that, right? But it is fun to try and guess. But you see what I'm saying? This picture, now, like I said, everyone's going to look at this picture and say like, oh, the vacuum nozzle's gone. Obviously, dude, a sea level engine is missing too. And not only is the sea level engine missing, but the other two that the telemetry said were broken are firing in this picture. Dudes, it's you call me crazy. Call me crazy. The second SpaceX tells us what happened, I will tell you if I'm right or wrong. I will own up to it and I will take accountability if my judgment is off, and I will use it as a learning experience. I think a sea level engine failed before the vacuum engine failed. I think that sea level engine quit. This motor. This one right here. I think that thing quit. And I think it quit hard. It was enough to damage the RVAC and blow it completely off the vehicle. That's my theory. I think the sea level engine went first. Like, call me crazy. I'm probably wrong. I'm just... The telemetry doesn't add up. You know what I mean? Because it says that sea level engine that's gone is still going before the vacuum engine quit. See what I mean? That doesn't make any sense. Why wouldn't the second RVAC be damaged at all either, though? See, Jackie, this is where we're getting into a bunch of questions. This is a fuzzy picture. How do we know it's not? You know? Also, what if that engine was gimbaled in one direction towards this vacuum nozzle to try and compensate for the differential thrust that we obviously see happening here, right? Right before the failure, you can see Starship, it has a huge differential thrust problem. And it's trying to compensate with gimbal and it can't. Look,
right down
look at the way it's moving. It's kind of slewing like this.
Where you can see
something is very wrong here, right? And then you get an engine failure. If that sea level engine was gimbaled to try and compensate for this yaw rate that's going on, and it was pointed towards the Vector engine, and it blew up, it would blow both of them completely off and seemingly leave everything else undamaged. See what I'm saying? Guys, once again, call me crazy. Call me a nut bar. It's fine. I think that sea level engine quit. This engine right there. I think that engine quit. You are a nut bar. I told you. Yeah, Lava, I just... But wouldn't that sea level engine have gone off telemetry first if that was the case? Well, Rocket Guy, once again, yeah, sure, it would have... If the telemetry was good. If we had good telemetry. We clearly don't have good telemetry. Once again, you know, you guys could say that that's... You know, you could say, oh, those engines aren't on. Those engines are absolutely on. You would not get that type of plume interaction if they weren't. Had the gimbal gone out, wouldn't it move towards the opposite direction? Well, Jackie, I don't think the gimbal quit. I think it was trying to compensate, and then it failed. And the way it failed blew off the Vector engine. That's what I think is going on here. Almond Nut Bar, thank you. Yeah, J-Volt, exactly. That's the... And once again, that is the big one here. It doesn't really matter how they quit. They quit. And that's not what you want. You see this right here? See that? That's no good. That's a good point. I'm digressing a little bit. I think that sea level engine quit first. But either way, guys, either way, this happened. What the hell's wrong with that wing? Maybe it's just the camera. Is the wing icy? There's a third Raptor vacuum still not visible firing in the view. It's still flow interaction, making it seem like the two sea levels are working. Yeah, exactly, dude. That's what I'm saying. Short version of what you're going over. Corn, long story short, you see how you could see 5 engines in the picture? 1, 2, 3. So 1, 2, 3, 4, and 5. And then an explosion happened, and these 2 engines just weren't in this picture anymore. An explosion that was induced from engines carrying non-uniform heating. See how there's hot spots on the nozzle right there? Explosions, the engines basically blew up. They melted enough to the point where they failed completely and exploded. That happens. That happened because there's a fuel leak. See the fire? You could barely see it. See the fire that's going on in that picture? There's a fuel leak. The fuel leak is absolutely because the fuel lines are broken. A fuel line broke off. Where did it break? Well, the fire is clearly downstream from the LOX tank because the fire is coming out the engine bay. So this thing failed somewhere below the methane and oxygen tanks that are on Starship. Starship has 2 big tanks. There's a methane tank right here. Then there's an oxygen tank right here. And then at the bottom, there's an unpressurized section that's about this big, right? That's an empty void of space between the bottom of the LOX tank and the top of your thrust structure. That's called the attic. That's what they're calling it for now. SpaceX calls it the attic in their press releases. Flight 7 had a leak in the attic. They had a leak in there, and they couldn't spray enough fire suppressant in there to put the fire out, and the rocket, Flight 7 basically melted itself from the inside out. Now, Flight 8, the fire was in the engine bay. It's in here, in this cavity right here. See this guy? It's in there. It's up in here. So it clearly didn't happen in the attic. The fire happened downstream from the attic, which is very interesting, which shows that SpaceX did put some type of mitigation in here. It just didn't work. Right? Yeah, Jackie, that's also a theory. Sure. Absolutely. I don't know. My gut's telling me that the sea level engine failed first, but we'll see. It doesn't really matter. This is all caused by leaks happening in the plumbing. The fuel lines coming from the methane tank going through the LOX tank and down into the engine bay are leaking. all of this, and this is the overarching thing, and J-Volt, thank you for steering us back. This is happening because of bad fuel mixture. Why is it bad fuel mixture? Well, your fuel is leaking out and catching on fire inside of the engine bay.
Shout outs to all of our avionics team.
Keep in mind that a full LOX tank will dampen the oscillations. Yes, exactly. That's another thing to take into account. SpaceX's fuel lines are going through their liquid oxygen tank. Any vibrations would be dampened by the fuel line trying to vibrate in the water. The liquid in the LOX. The LOX would basically stop the vibrations from happening. So when you get to a certain quantity inside of the tank, the LOX drains low enough, the lines will start vibrating like crazy, causing harmonic resonance. That's a big problem. It's a problem that they need to solve. Obviously, you don't want more Turks and Caicos firestorms happening, but anyway. Either way, this is happening because those fuel lines are leaking. The new resonance issues, regardless of the new propellant feed lines, is likely caused by increasing the length of the vehicle. Longer vehicle, more oscillations at different frequencies. Yeah. Yeah. Please repeat about the absorption assumption. It's not an assumption, it's a fact. That's what's going on. When the LOX tank is full, the fuel lines, which are vibrating like crazy, it gets dampened because they're submerged. Right? It gets dampened out. The liquid oxygen is acting as a shock absorber to prevent the lines from vibrating like crazy. See, these are your proverbial fuel lines. When the liquid oxygen drains, they can start vibrating like crazy, which is why we saw failure, Chief, at pretty much the same spot.
Discovery, go at throttle up.
They test fired it with a long duration test fire. What if the V2 Raptor is too powerful for the hot staging? 60 seconds is not... 60 seconds is enough to prove that the lines vibrate, Journey. It's not enough to prove anything else. How would binding all three downcomers to the center one in sort of a strut spiderweb fix the situation? That's certainly a mitigation, but you're adding mass at that point. It could work. Guys, okay, so we're returning to the V1 downcomer design fix the issue. No, I mean, Lava, that would fix the issue, but, so, okay, a little bit of retrospect here. We know pretty damn sure what happened, all right? How do you fix this? And so I think there's two important questions to ask here in the wake of Flight 8. A, how do you fix this? And B, why hasn't SpaceX fixed this? Right? Same failure 2 times in a row. Not great. Not a good thing. Right? Is it possible for them to do a full duration static fire? No, Yanix, it is not. And I think that feeds a little bit into why they haven't fixed the problem yet. So, SpaceX made a lot of mitigations to this. Mitigations. Important to understand what that word means. They made a lot of mitigations to Starship V2 for Flight 8 to try and beat the fuel lines shaking themselves to pieces. They added a bigger fire suppression system. they added a more fire suppression, and they probably changed the engine throttling regime just a little bit to try and not induce that crazy of vibrations, right? Now, with all that being said, it clearly didn't fix anything. They had this almost the exact same failure. I think they had a fire in a different spot. If you really want my honest opinion, this one made it all the way into the engine bay. It wasn't just in the attic. This one was in the engine bay, so whatever they fixed in the attic, they just moved the problem downstream and caused an engine to blow itself off the back of Starship. More struts. Yeah. You could strut your fuel lines, but you got to remember the fuel lines are vacuum jacketed. That's important to understand. It's hard to stabilize a vacuum jacketed line. Okay, you strut the outside. What about the fuel line inside? Right? Hard to do that. It's not easy to do. You need dampers. Sure. Sorry to distract. Faust has blue targeting August 2025 for Blue Moon Mark 1. Okay. Jackie, you forgot they were jacketed? How dare you not jacket in my jacketed chat, you vacuum insulated Jackie line. A tighter jacket? You saying I'm fat? More flexible material. Sure. I mean, okay, so once again, I wanted to get into A and B here, dude. Hear me out. Hear me out. So why didn't SpaceX fix this problem? Well, like I said, they put in mitigations. That's what I was saying. They put in mitigations. So what are mitigations? They're ways to kind of address the problem, but they're more of a Band-Aid fix. Okay, ask yourself this. Ask yourself this. Is SpaceX the kind of company to Band-Aid fix something? If the answer is yes, well then, yeah, they failed 2 times and they're not having a good day. If your answer is no, I would say you're agreeing with me. I think, personally, that they already have the fix to this problem. Or at least a potential fix, a potential permanent fix lined up. You guys are saying, oh, just strut the lines. Strut the lines more. Come up with another way to damp it. Put the line on a shock absorber. Something. Yeah, sure. Put flex joints at the top and bottom of these jacketed lines so that it allows them to move and sway. Sure. Those are all ways to fix it. Those aren't mitigations. Mitigations are different. I think that SpaceX has a potential fix for this problem. But because SpaceX is running what's called a hardware-rich space program, they're running a hardware-rich program, meaning they make a lot of things, meaning they have a production line, meaning that a potential fix is not like the permanent fix is not going to come down, quite actually down the assembly line for a couple of flights. So what do you do in the meantime if you have a potential fix? Like a permanent fix, you mitigate things. That very much sounds like SpaceX. I'll give you an example. Block 4 Falcon 9, not very reusable. You could reuse it maybe 5 to 6 times, maybe. Right? So SpaceX did what they needed to do to get those boosters, to try and extend the Block 4 Falcon 9s, to try and reuse them as much as they possibly could. And they mitigated all of their problems. Meaning the boosters needed a much bigger turnaround time between flights. Block 4s took months before they got ready to go again. Until Block 5s rolled around, and now a Block 5 booster has the potential to be turned around in 3 weeks, not 3 months. You see what I'm saying? SpaceX will implement mitigations like this. Historically speaking, they will implement mitigations like this when a fix is coming, but they haven't retooled their industrial base to build that yet. Meaning, They already probably have a fix in the works. If I had to guess, there's probably a fix. It hasn't made it down the assembly line yet. That's my guess. See what I'm saying? So until then, what are you going to do? Not fly? SpaceX doesn't do that. They want to fly. They want to get as much flight data as they can. Flight data is king, especially booster catching data. That's really, really important. Because I will say this. I will say this once, I'll say this again. Starship thermal protection systems are a very, very big thing to understand. And obviously getting your second stage into space is something that you don't want to, you want to happen. You want to make sure that it gets into space. The most important thing for Starship's overarching flight architecture in the future is being able to rapidly reuse Super Heavy. If you can't rapidly reuse that thing, the whole program is worthless. Think about it. Yeah, you heard that right. You heard that right. If you can't rapidly turn around your first stage, who cares if you can reuse your second stage? It doesn't make any sense. And the first stage is the thing that does the brunt of the lifting, right? If you can't reuse... Now, hear me out. You say if you can't reuse the ship too, the program is worthless. False. That's not exactly true. That's not true, Graham. SpaceX could still do HLS using expendable starships. You could absolutely do it. Obviously, if the thing doesn't get into orbit, you're not doing anything, right? You could operate the HLS program with expendable or non-reusable starships. You cannot operate HLS's flight regime with expendable super heavies. That is not happening. You can't expend 33 engines over 16 flights in less than a week. There's no way that that's happening. You can't do that. That's what I mean about Super Heavy being more important than Starship at this juncture. Because if SpaceX wants to launch HLS, obviously they have to get the stupid thing to work. You have to, first and foremost, if your second stage can't make it to orbit, you got a big problem, right? But that's a problem that I think they've already implemented the fixes for. I think what these mitigations that we're seeing are just them basically biding their time so they can get flight data on that first stage on Super Heavy. Because I think Super Heavy is the most important part here, save for maybe Mechazilla. Interestingly enough, I think Starship is kind of like the least on the lowest on the priority list. I know that sounds stupid. I know it sounds dumb. I get it. You could operate, SpaceX could send Artemis 3 to the moon using expendable starships. They cannot do that with an expendable launch pad or an expendable first stage. You can't do that. That's not happening. I mean, you could. SpaceX would be out bajillions of freaking dollars. First stage reuse is tantamount, which is why I think SpaceX focused on that first. They basically froze the ship design at Block 1, right? And worked on Super Heavy. They went from 29 engines to 33 engines. Then they added the chines. Then they added the spin start. That's super. We saw a lot of upgrades to Super Heavy and not so much on Starship. You started to see upgrades on that once, basically really once Super Heavy was able to do a precise landing out in the ocean, like I think it's Flight 4. That's when you started seeing some big changes to the ship. And ultimately Block 2, which is what I'm talking about. It takes a second for the fixes to get implemented on their production line. Does that make sense? What do you mean spin start? Raptor engines use spin start mechanisms. They have a pneumatic starter motor. Yeah. They shoot compressed nitrogen into the preburners and get the preburner, well, the gas generator part of the preburner. They shoot gas in there and get them to spin extremely fast. And that gets the fuel pumps working, and then they let the engine go. Then they turn it on. Like I said, the spin starter for Raptor is basically you cranking over the car engine. That's the spin starter. What does a starter motor do on a car? Well, you have switch 12 volts. You send switch 12 volts through a solenoid to the starter motor, and the starter motor turns the flex plate or flywheel, and that starts rotating the engine enough to where the engine can turn on. Make sense? I tried to address that on X today, that arguably Starship is on schedule for success failure rate for rapid iterative development to maximize learning. Rocket Guy, that leads me to part B. You know, these mitigations are basically them biding their time. Part A is they're basically implementing this stuff knowing that it could possibly fail. They're implementing mitigations to try and get it to work. Is this problem unsolvable? No. Does SpaceX have a fix? Yes. Will the fix come down the pipe? Yes. Is it the end of the world? Absolutely not. I think they are running the course. To be 100% honest, I think this is fine. The optics of it can't be ignored. Raining fire down on the Caribbean is probably not the best PR for your company. Probably not the best, but I agree with you, dude. I think that, and this is part B, I think that this is following a rapid iterative process. I think the fix is already found. And in the meantime, they're just mitigating problems. Once again, they even call them themselves. They're mitigating the design flaws, but they're still going to fly. They launched Flight 8 knowing full well it could fail. It could fail catastrophically. And my question back, to anybody that says, oh, why would they do that? Why would they just expend to starships like that? How is that different than any other flight? Right? How is that different than any other flight? The real problem is the optics, especially with, yeah, exactly, Yarg. Yeah, the optics can't be ignored. I think the optics are magnifying this failure and making it look a lot worse than it actually is. Surely Taker Starship can't be expendable for Artemis. They'd have to burn a dozen or more. So, launch them without thermal protection system, Slab. If you're going to expend it, why does it need tiles? See what I mean? You could get away with it. SpaceX can hold up their part of the Artemis program with an expendable ship design if they really needed to. They absolutely cannot do that with a Super Heavy. No way. That has to be rapidly reusable. If it's not, the whole program fails miserably. Next flight was going to do a catch. I don't think that that's going to happen, Baron. But, it might. Who knows? But I don't think that this is going to hamper the program. I really don't. In fact, I would say early May for the next flight at this moment in time based off of what I've seen. Hey, Leglander, thanks for the raid, buddy. If you want the technical backup for this process from reliability engineering, sure. I think Ship 35 is going to fly a lot sooner than everybody thinks. Ooh, Rocket Guy, great thread. I have relativity stuff teed up, dudes. I will show it to you guys in a moment. Let me just put the SBL up there. We already went through that. Rocket Guy. All right, what do you got here for me, dude? Hey, Rocket Guy follows me. Like I said, the optics can't be ignored. That's bad. That's very bad. Once again, see all the twinkling? All the twinkling is tiles that are flipping end over end. See all the flickering lights? Those are parts of the spacecraft with tiles on them that are flipping end over end. This debris propagation also shows a very violent explosion happened. Just on a side note, an extremely violent explosion, judging by how the debris is all spread out. Most likely a result of Starship spinning too much. Spinning and just ripping itself apart at the seams. That's my guess. The optics can't be ignored. That's not great. Ooh, a COPV popped. Look. In this footage, a COPV popped right there. Watch. See? Spoof. See that? Oh yeah, see that little guy? A COPV exploded. Ah, that's pretty neat. Did you see that? That's pretty cool. We saw a COPV explode. That's what that bright thing is. That's the gas from the COPV popping. The flight termination system was disarmed engineer, they either were able to manually override it and issue a manual flight termination system, or the vehicle exploded from spinning out of control too quickly. As much as I don't want to bring this up, that's what happened to Columbia. Columbia, turns out flying with one wing makes you spin around like crazy, and the shuttle spun so fast it basically centrifuged itself to pieces with people on board. Not great. Now, don't get me wrong, Starship did not have anybody on board. This one had no one on board, but spinning will kill you during re-entry. I don't think that's a shocking revelation, but that's what happened. Starship most likely broke up from spinning out of control too fast. Basically, it started spinning like crazy and basically stretched itself. Tension force basically ripped the vehicle in half. Astronomy Live has a telescopic view of Starship re-entry. I've seen it. It's pretty cool. It turns out spinning is not a good trick. Well, rolling is a fine trick. That's fine. Flipping end over end is not a good trick. Yes. Anyway, Rocket Guy, what's up? So, I've seen a lot of these types of ill-informed comments floating around. What does this guy say? If you're keeping count, that's 4 Starship explosions out of 8 attempts. An impressive failure rate. Elon's philosophy seems to be the same for everything. Blow it up, waste billions, and call it in a... Okay. So, I can say with a very high degree of confidence, Rocket Guy, that man has no idea what he's saying. Like, no idea. And, I'm not defending Elon or anything. You literally have no idea what you're talking about. It is very, very funny that guy is weighing in on this like that. Thinking, that's like peak Dunning-Kruger, dude. Like, I don't know what to expect from a politician, man, but whatever. Okay. It's true that Starship's flight test record is 4 successes in 8 flights. This begs the question, is it failing too much? Let's clarify with reliability engineering and information theory. All right, Rocket. You know what? I'm going to like this thread for visibility. Uh-oh. Math is coming. Math is coming. Oh, boy. All right. Optimal failure rates aren't random. They're mathematically proven to maximize learning about a system. For simple success failure outcomes, maximum information gain entropy occurs at exactly a 50% failure rate. Maximum information gain entropy occurs at a 50% failure rate. P equals 0.5. Binary entropy HP equals negative P times log 2 P plus 1 minus P log sub 2 1 minus P. However, to be fair, Starship isn't a simple binary system. It's an incredibly complex system of systems. There's a lot of moving parts. For complex multi-component systems modeled by exponential distributions, the optimal failure rate is different, approximately 63.2%, exactly 1 minus 1 divided by E. This can be derived by first assuming an exponential reliability model. Failure probability equals 1 minus E up to the minus theta t, or lambda t, excuse me, where lambda is the failure rate and t is time or exposure. Maximizing information about lambda leads mathematically to an optical failure probability of 1 minus 1e equals approximately 63.2%. But with this said, even though Starship is complex, one can argue its iterative test strategy resembles binary experiments, pure successes or failure outcome, making the about 50% failure rate practically optimal for rapid learning. Cool. Half-Life reference? Is there a 3 anywhere up here? Oh, there's a 3 right there. Half-Life 3 confirmed. Boom. Roasted. 6. You can harp on SpaceX and their failures if you want, but Starship's testing performance isn't problematic, but ideal for rapid learning and innovation. Each failure is intentionally driving progress. SpaceX is using a different engineering process. Let's see what happens. So I recommend that people refrain from these types of comments until Flight 9. If that fails, then something more can be said. It is technical, but I wanted to show that based on reliability engineering, their current rate maximizes learning. Of course. Okay. So that was a lot of numbers for some people. Okay. What Rocket Guy is saying. What Rocket Guy is saying there, essentially, is that seeing the ship blow up in your face makes it really easy to see what went wrong. That's the plain English way of saying it. The biggest failure is going to help you learn very quickly what's wrong and what isn't. Right? There are a lot of new hypercritical SpaceX sycophants, and Twitter is basically pure propaganda. I don't understand what that means, but all right. We're talking about spaceflight systems engineering and reliability engineering information theory. What does that have to do with Twitter? He's saying if ships don't blow up, you're playing it too safe and not learning as much as you could have. Big time. Because higher failure rates mean your vehicle's actually flawed in design. A lower failure rate means your testing isn't likely good enough to find its actual operational capabilities. Space shuttle! Space shuttle! Rocky guy, sorry, I need another cough drop. Space shuttle! The issue was politically based criticism, yet SpaceX is also becoming a little like in another direction. I guess. I'm not exactly sure what bearing that has on reliability engineering, but all right. Godness, that sounds like you got a Cygnus. Yeah, I'm down with the Cygnus, dude. So is FedEx, apparently. Moon, I'm not going to lie. I'm being obtuse on purpose. I understand that Elon runs SpaceX and Elon is a highly politically charged figure. I would very much prefer it if we stick to reliability engineering and information theory and technical analysis on the Starship program, refraining from getting into the political sphere as much as possible. I don't want to do that. Why? Because everyone, like you, is trying to shoehorn a political opinion into this technical analysis. And frankly, that's very annoying. I'm sorry, I'm not trying to be mean. I would prefer to stick to the numbers. All right? I don't want to discuss politics here. Politics is in our lives 24/7, 365 nowadays. Can I just sit here and talk about numbers? Is that fair? I think that's fair, dude. I think that's pretty fair. Just let us nerd out about rockets, man. Okay, okie dokie. You've taken a meta perspective, no pun intended. I see what you did there. Anyway, Rocket Guy, I think that's fair. I think SpaceX is learning the most from this. And while the optics aren't the most ideal, dude, I would say that they've come up with a fix for this problem really quickly. Hey, Blue, what's going on, bro? Yeah, Yuri, we all did, but that ship sailed a long time ago, okay, man? That ship sailed a long time ago, bro. This is why we have Rule 8. Guys, after the whole fiasco with Elon getting into getting into it with astronauts, I don't really want to discuss anything that he says. I think that's fair. I don't want to put that on you guys. You guys don't deserve that. I'm your entertainment. We'll stick to nerds and nerddom and numbers, okay? That formula has never failed me in the past. With that being said, Moon, I'm still not 100% sure what you're trying to get at. So, because I don't understand, I said if Your hypothesis ends with some political jargon. I don't really want that type of environment in here. Is that fair? You think so, Sawyer? The rocket that blew up recently, what was that mission for? So, Murray, it was a test flight. Starship is a test program. It was a test flight, dude. SpaceX is trying to work on... I know, this is going to sound like PR speak. Please forgive me. SpaceX is trying to work on building a rocket that essentially is able to fly like an airliner. That's the whole idea. They're trying to make something that can be turned around as quickly as an airplane. Now, I don't know if you've seen from like the space shuttle and stuff that's really difficult to do. It's really difficult to make a rocket work like an airplane. That is an extremely tall order. And SpaceX has seen it fit to go about doing this using what's called a rapid iterative approach. Meaning, and this is what Rocket Guy was mathematically talking about. Rocket Guy, thank you so much for this. This is actually a super good way to put it into exact numbers. I could sit here and discuss what binary entropy is if you really wanted, or I could just explain it to you in plain English. SpaceX's rocket blew up. It failed. That is the best way to learn where your design flaws are. That's the best way to learn what not to do. Now, simultaneously, that's also the most expensive way to learn. Over the past 30 years, probably 40 years in spaceflight, we've been trying to, NASA or whomever, any spaceflight endeavor has been trying to not learn the hard way because it's expensive, right? You don't want something blowing up. It looks bad for your company. It looks bad for your space program, etc., especially if there are people on board. NASA, I'm looking at you, right? It looks bad, right? SpaceX, and obviously, with NASA, you have the possibility of less funding because you screwed up, and with a private company, it looks bad. You're less likely to get investors. Nobody's going to invest in a rocket that blows up. So what's the thing with SpaceX? What's the deal here? SpaceX has the cash to be able to fail quickly and fail very fast. Okay, they have the money to do it. So yeah, the rocket blowing up is not ideal. It's not great. You don't want that to happen. But simultaneously, you're trying to build the most complicated vehicle. This is the quickest way to do that. It's the fastest way to build a vehicle that is actually rapidly reusable. Because in the past, we've tried to mitigate this and tried to learn, quote unquote, learn the hard way as to what makes stuff work correctly, right? Like with the space shuttle, that whole, we don't want to look bad, and then you end up looking bad because your engineering wasn't good enough and it didn't expose the design flaws in your spaceship. All the design flaws are being exposed in this thing through its rapid iterative prototyping. And the sooner you can fix those things, the less likely you are to get O-ring failure, quote unquote, right? The space shuttle wasn't, long story short, what I'm trying to tell you is that space shuttle wasn't tested enough. It was not tested enough before they put it into operation, and they didn't test it good enough, and they found something wrong with it, and that ended up killing 7 people. And then killing 7 more 20 years later. Well, 17 years later, but you get the idea. SpaceX has basically looked at that and said, that's a real dumb way of doing things. We're not doing that. And they're testing it uncrewed with nobody on board, trying to find these design flaws as much as possible to actually build something that's fully reusable. Does that make sense? When is the next NASA milestone for payments to SpaceX? I don't know off the top of my head, David. I'd have to look. Can you talk about the vacuum insulated plumbing that seems to be the case of failure? And how will the new Block 2 flaps perform when they get to re-entry? I think the Block 2 flaps will perform just fine. I think SpaceX has had, I think the flaps on the front and back of Starship are already too big. Making them smaller and moving them out of what's called the bow shock slab is a very smart decision. So they don't get the burn through that we encountered on Flight 3 and 4. Yeah, Murray, that's what's going on. So yeah, oh yeah, the thing exploded. It blew up good. But, and this is what we were talking about. This is what Rocket Guy was talking about in chat, and this is his post on X about the exact thing. Basically, mathematically driving this. Long story short, having it blow up in your face is going to teach you real fast how not to fly this thing. Right? Failure is the best teacher, man. And SpaceX, yeah, they are failing a lot, but they're also learning a lot. Right? People confuse that with, oh, they're just, shooting from the hip and, seeing what works. Well, yeah, to an extent, sure. But the alternative of that is being careful and then declaring it operational well before it's a mature design and then flying 7 people into space and having the O-ring fail and blow up. See the differences? They're using past programs' lessons to build this thing. And that, now, once again, that's going to get us to an actually fully reusable vehicle. Now, once again, I told you that this is the most expensive way to do things. What, does SpaceX not have money? I think the people involved, the stakeholder expectations, or the primary stakeholders in SpaceX have very deep pockets. I think that would be a good way to put that, right? So that's not a problem. So if money is not an issue and you want to get this thing working, well, there's that old triangle of, do you want it done fast? Do you want it done right? Or do you want it done cheap? If you want it done fast and you want it done right, it's not going to be cheap. SpaceX can do that right now, which is why we see these starships failing all the time. Right? Rocket Guy, what did you say about binary entropy? Binary entropy is a fancy way of saying something like the learning rate from 50-50 success-failure outcome. So to maximize learning, i.e. to maximize that binary entropy function, you need to get a 50% success-failure rate. So you're essentially failing, learning, and fixing on repeat. And Starship seems to follow that problem completely. See, and that's, Rocket Guy, I'll take this one further. That's how I know you can mathematically prove that this guy doesn't know what he's talking about. Because he's thinking about spaceflight in the same way that the shuttle program thought about spaceflight. Oh, you're not succeeding all the time. If you're not succeeding all the time, you're failing all the time. And if you're failing, that's bad. This mentality, ironically enough, and it's funny because this guy's a politician, right? That mentality, oddly enough, is how astronauts get killed. To move this one further, politicians controlling how the space program works gets astronauts killed. Challenger was a political decision to fly. So was Columbia. It makes sense. Math checks out. Per Rocket Guy, the math actually checks out. The only thing that NASA learned from the shuttle disasters is how to turtle.
Discovery.
Bear, that's a good way to put that, dude. Chad. Thanks for that Prime sub, dude. I appreciate it, dude. Someone asked this before, but why wouldn't SpaceX mention that they expect the flight to fail? To prevent reactions. They say that at the beginning of every cast, dude. Kate and Dan said that right they said it in this cast. They said it's possible that it can blow up. They say that all the time. Go listen to the cast again. Apollo 1-2. To an extent, NG, that was more engineers not doing comprehensive analysis. But yeah, sure. Oh, yeah. Dude, they say it every cast. They say this is a test flight. Excitement guaranteed. That's what that means, dude. You're either going to be excited from a really, really successful mission or excited because there was a gigantic explosion and haha, explosion cool. That's what they mean when they say that. They're talking exactly what Rocket Guy is saying. They're saying the same thing. It's just in a different way. Junie. Tone it down. Tone it down, brother. We got to teach people. Remember, we got to teach people. Tone it down just a little bit for me, dude. Tone it down. Just dial it back. You're at like a 10. I need you to be at like an 8. You know what I'm saying? Animal, what's on your mind, dude? With SpaceX's testing regime is like a baby learning to walk. First steps are difficult, and once they get it, they will still stumble and fall from time to time. The only way to get there is trial and error. Yep. We got to teach people, man. I'm not going to be that guy. We're teaching people. That's what we do. All right? I need to get back to basics with that. We must teach the ways of spaceflight. We have ways of making you space. Please, somebody screenshot that. We have ways of making you space. Do rockets need to be pointy? I know Elon loves telling people he only made it pointy because of a movie. How come all other rockets are pointy? Bullets too. They're not. They appear pointy, but they're actually not. That's a super good question, LS. Here, I'll show you. Do you want to see what honestly is the most kind of ideal for going at hypersonic speeds? I'll show you. I guess the first thing I'll show you is Falcon 9's fairing. This is a picture from SpaceX of the fairing when it's floating in the water. This is the aerodynamic shell. So this right here is the very top of the rocket. Does that look pointy to you? It's not a trick question. No, it's not. It's more hemispherical at the top. It's like a half circle. See? That's the best type of aerodynamics at super high speeds. Starship doesn't need to be that pointy. You don't need to. Now, why? Why? Okay, it's not pointy enough. Ha ha ha, that's a joke. Why? Okay, because at a certain speed, you get what's called a stagnation at the front of the vehicle. This is aerodynamics now, so we're going to get a little bit of rocket science here. Or, well, aerodynamics. But you get a point of stagnation at the front of the vehicle. Basically, air builds up on that hemispherical part, on the very front of that fairing. Air builds up and actually makes it aerodynamic for you. You don't need to do that. You don't need to make it pointy. Making it pointy is more rocket that's there that doesn't need to be there. That was the idea.
Discovery, go and throttle up.
I'll show you exactly what I mean. So, Falcon 9's fairing kind of goes like this, right? It goes like that. And most rockets have this kind of weird hemispherical front. What happens is oncoming air, or what's called laminar flow. Laminar flow is a nice way of saying clean, undisrupted air. Okay? When it gets to this point, that air is going to go like this, right? This air that's right here is going to go like that. This air right here is going to do something like this. This is going to do something like that. Now, why? Well, air basically gets built up right here at what's called a stagnation point. And that basically creates a low pressure pocket right here. And the oncoming air flows around that compressed air. Aerodynamics makes the point for you. Cool, huh? It makes the point for you. It's weird, I know, but that's why it's aerodynamics. It's not very intuitive.
Go and throttle up.
A point is actually super bad for a rocket. It's bad for heating because you don't have that stagnation point. That stagnation point pushes the air out to the sides, and that keeps the hot air, re-entry heating, away from your vehicle. You're always going to get entry heating on ascent. There's shock heating that happens because when you compress a gas, it gets warm, right? The ideal gas law, PV equals nRT. Compressing a gas makes it get warm. Decompressing a gas makes it get cold. If you've ever had like a CO2 BB gun or a paintball gun and you shoot it really, really quickly, the can gets cold because you're decompressing a gas. Cool, huh? Same kind of idea with a rocket, with the front of a rocket, right? If you have a pointy rocket, the hot air actually stays next to your vehicle and it compresses up against it. It actually stays close, right? It doesn't compress up against it. It stays close and it heats everything. having a hemispherical design like this makes that stagnation point. It does compress air up at the top to an extent, which is why you can see right around here, it's a little burnt. The nose cone's a little bit burnt right around here, but it pushes most of the air away. It makes the point for you. Dude, once again, that's not, and I know if anybody here actually isn't screws with aerodynamics, I know those aren't the right words. I get it, but that's the gist of it. It's not exactly right, but that's the idea. Here, I'm going to see if I can find something else. Here, wind tunnel image. I'm trying to show you guys like a picture of how this kind of all works. This stagnation point, these stag points happen all over the place. They happen with cars, believe it or not. Look. So this is it's a render of a car going through a wind tunnel, but see what I'm talking about? There is a reason why cars have a splitter up at the front. The splitter holds that air right there, and basically that air pressure pushing down on the splitter pushes the front tires into the ground, giving you better traction on the front wheels. But it also air dams this stuff right here. It holds a lot of air right here to get most of the air to go up and over. This is also the exact reason if you really want some crazy ideas. So do you guys like NASCAR? Anybody like NASCAR? Phoenix was stupid. I didn't like that race at all. For what it's worth. NASCAR's like the bump draft. Right? NASCAR's bump each other. They get, you see people basically driving right up and bumping somebody. It's called drafting, right? The cars bump each other. Now, I don't know if you guys notice, if you do actually watch NASCAR, when the cars bump each other, they go faster. Why is that? You're replacing your stagnation point with another car. There's no air that gets compressed up here. There's just the air flowing over. So that basically creates... Now, once again, this stagnation point does create drag, of course. Anytime you get air compressed up here, the car is trying to push that air out of the way, which is why the splitter is going to push those front wheels into the ground. But if you replace that with the back of another car, the laminar flow basically flows over the car completely, and there's no stagnation point. So this car basically has a fairing on the front. It has a fairing on the front, like the SpaceX fairing. Same idea. Like the fairing shields the payload, right? And the cars can actually go faster. So that's what Elon said when he said, you know, it's too pointy. It doesn't have to be that pointy. You can actually make it stubby, and it'll fly better at higher speeds. Weird, huh? Yeah, King, that's actually a pretty good picture. I mean, I'm pulling this off the top of my head, guys, but yeah, there you go. See? The air doesn't go into that point right there. It just gets stuck and flies over the car. And the cars can go faster that way. Bulbous bows on ships too. Yeah, sure, Chief. That's another good example. The bulbous bow is doing the same thing. But that's hydrodynamics. That's not aerodynamics. So it's, you know, fluid compressible, fluid not compressible, air compressible. But yeah, that's the same general gist. Yep. Still fluid dynamics, no doubt. Does that help? With the pointy Elon question? I didn't think it was in the atmosphere long enough to worry about it once it's past max Q. Max Q is peak aerodynamic load on the vehicle, dude. That's when the vehicle can't move the air out of the way fast enough, and you're going to start to really induce compression load. It's drag-induced compression load on the vehicle. It'll basically start trying to squish the rocket. But that, once again, you're right. That only happens for a second. But you got to remember, the rocket is flying through the atmosphere for about 90 seconds to 120 seconds, like, of flight. You know, it gets high enough above the atmosphere, basically at staging. That's still a quarter of your flight regime for the vehicle. That's a lot to take into account. That's a lot of air to move out of the way. Think about all the air that needs to pass over that vehicle. It's enough that they have to worry about it, dude. So why doesn't Starship use a pointy nose? It does use a pointy nose. But even at the front of Starship, you still see a hemispherical front. Why don't they put divots like golf balls? The divots make the ball fly smoother, further, and faster. King, you could. Hard to manufacture. Geez, keep hydrodynamics out of this. So assuming the binary model for development, when do they move away from that, less into development tempo? Oh, that's a good question. You would want to move away from that model when you reach what your stakeholder expectation goals. Right? But the goals shift. Right now, your stakeholder expectations, like, think about it like a subset of the entire Starship program. Okay, what's the problem that we're dealing with right now? The problem that we're dealing with is getting Starship into orbit. SpaceX can't do that yet. They've gotten close, and they've intentionally stopped, right on the cusp of orbit on purpose with multiple flights, with Flight 5 and 6, right? They're trying to get to orbit and trying to get to orbit reliably so they can test their deorbiting systems, make sure their deorbit burn works correctly, make sure their payload deployment mechanism works correctly. Because you're not going to send Starship into orbit without knowing for absolutely sure that it can come back down. You don't want to strand a 150-foot building. I said that on the NSF cast, damn it. I called Super Heavy a 220 story building. You don't want to strand a Starship on orbit and have it not able to come back down. That is a very, very, very bad idea, right? So SpaceX's current thing is get to orbit. That's their big one. Once that gets met, right, then you switch to other things. You switch to figuring out refueling. And then once all your stakeholder expectations are met, right, that's when you move away from that. That would be my guess. Golf ball dimples, that's easy to manufacture. It's Texas. Leave it out in a hailstorm. Would Starships ever be able to dock with the ISS? Maybe, Jackie. Who knows? We kind of have a scenario where I can't really accurately predict the future of the space program. I wouldn't say that that's out of the realm of possibility. However, I will say that that's pretty unlikely. Yeah, as soon as SN-15 landed, they were like, okay, we're good. Move on to other testing. Yep. My answer to that question, typically you transition from... So Rocket Guy, this is your answer. Typically you transition from binary testing, maximizing learning, to sustained high reliability operations once major uncertainties are resolved. Big stakeholder expectations, yep. And your design matures. At that point, the goal shifts from discovery to consistency, safety, and repeatability, typically after core subsystems demonstrate stable, predictable performance. I assume you got L2. No? Why would you assume that? I don't have L2. Baron, I don't know if you've noticed this. I analyze what's going on in the space industry without outside people telling me exactly what's going on. That makes it so, one, you're going to get a very, very different analysis on things here on this stream as opposed to everybody else. And two, it also trains me to learn and understand how this stuff actually works. If I make a hypothesis about something, like the sea level Raptor engine failing first, which I think is what happened, right? If I make a hypothesis about that and that turns out to be true, that tells me that I'm thinking about this correctly. If it's not, that tells me that I'm not, in which case I will get better at it and learn from learn from your fails, right? Like SpaceX, and make a better analysis next time. Does that make sense? So no, I don't have L2. I don't go on there. Yeah, the tile testing is going to be something cool when they finally get that thing up there. What time do you call this, young man? You were supposed to be back 2 weeks ago. How was your work trip, huh? I've heard you've been talking to other stream chats behind our backs. No. L2. L2 is NSF's paid forums. There's a lot of industry people on there that talk about failures. Great for insight if you want to learn, but that's just if you want to learn. I want to learn with you guys. I don't have L2, says the guy with lifetime L2. Nah, I don't have L2. I have L3, son. Yeah, nobody knows about that. That's just the NSF control room, to be honest with you. I guess, yeah, I suppose I could go on there, but I don't. I don't go on the NSF forums too much. Go check the Flight 8 thread. Can't post much. Neat, Baron. You had me call me a nut. Yeah. I feel like if the first V2 there goes through re-entry, we'll see some control issues. Is it just you? I don't think so, Jackie. I really don't. I would go. This is, once again, my personal opinion. This is my personal opinion. I'm not getting information from anything else. This is just my kind of looking at it. Honestly, this opinion is based off of what I saw in Kerbal Space Program. I'm not going to lie to you. I think the control surfaces, the aft control surfaces, are way too big. I think they're too big. I think they can be way smaller. In fact, I would remove that completely and just put a static strake. Yep. Yeah, you heard that right. I don't think Starship needs aft control surfaces. That's just, once again, that's just like your opinion, man. Do you think the primary differences between V1 and V2 is that much of V1 was structurally reinforced as V2 they were removing more to get more cargo into orbit? Hey everyone, what's up, dude? Dude, I think that the V2 Starship is built around Raptor 3, and I think that's kind of why they're having problems. I think Raptor 3 is the proverbial fix. Call me crazy. I'm gonna go sit in the corner with a dunce cap. I was told there would be no math. Why do you think Booster 15 had those top 2 bars? Kind of looks weird and janky. I don't know. Top 2 bars? Top 2 bars. I don't know, man. But Elon said that they want to remove the forward control surfaces. I really don't think you should remove the forward flaps. You had a good time in Margaritaville, man? It was a sad drive back Thursday night. Wait, Thursday night? I mean, yeah. It launched on Thursday. Ruin, what day were we hanging out? I don't freaking remember, dude. I don't remember. For multiple reasons. The big reason is because time was a blur down there and I had a lot of fun. The other reasons... You know? Ooh. Uh-oh. Let me see, Jackie. Jack-a-wacky. Reinforcement. That top part is get it. Wait, what the hell? It was Monday night, but I stayed to watch the launch. Ah, you said because it blew up? Who cares, dude? Who gives a frick? They'll launch another one. Dude, this isn't going to delay snot. It's just a harder problem to solve. All the problems from here are going to be harder to solve. Don't worry about it. It's fine. They'll get it. Wait, you never saw this? No. Okay, call me nuts, Baron. The only reason you'd put 2 bars across the top of a booster like that is if the whole booster is doing this. If the booster is not concentric, that is there to keep it from bowing on this axis. So like this is the long axis of the booster. There must be some kind of load here that is causing this ring to bend like this. Keep it from bowing. Ah! Oh no, Aqualux. Oh no. Catch pins. Yeah. Exactly. Well, the catch pin is pushing up, and yeah, dude, it must be bending the booster. Oh. Yeah, if the catch pin is pushing up. Oh. Oh. Maybe that's why they're not using booster 12 again. Or 14. Yeah. Yeah. Now, Archie, keep in mind what you could do if 14 was... 14 clearly didn't get as toasty as 12 did, right? I would say you could refurbish 14, right? Like, I mean, you could retrofit this on there if you really wanted to on 14. I don't think they're, okay, so what's my big driver between like, oh, they could do it to 14 and not 12. 12 is outside. Yeah. Normally SpaceX, once it reaches the rocket garden, it doesn't get used again. I'm just putting it out there. 14 is still in the Mega Bay. So 14 is still in the Mega Bay. They're either scrapping it or they're modifying it to do something. Am I right? It's in Mega Bay 1, right? In fact, I saw it the other day. I saw it when I saw Booster 15 roll in. Hey, Rival Sling, what's up? Here is picture of it rolling into Bay.
Oh, this is space. I'm in space.
Pigeon! If you want an understanding as to how big this thing actually is, note the dude walking right there. See that? Note the dude walking. Now note the booster. See what I'm talking about? It's super heavy is not small. It's not small. It is a large piece of equipment. Does 15 have V3 Raptors? No, it doesn't. Didn't look toasty to me, David. Just the top. The top steel around that ring was tempered a little bit. But that's about it. Man, even the SBMTs are huge. Jackie, I'm 6'4", 6'4", the deck of an SPMT is right here for me. Yeah, SPMTs, you think they're about this tall. No, 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 no. They're up here somewhere. I'm 6'4". They're probably about 5.5 feet off the deck, so like 1.5 meters for the metric people. Yeah, I stood next to one during camera setup with NSF. I stood this close to it, from me to the chair. I took this measurement for this exact reason, because I knew somebody would eventually ask me how big SPMTs are. I purposely figured this out for this exact moment. So in Danger Lot, where Starhopper is, right? They have the SBMT that moves around the Raptor dance floor, which is the servicing structure when a booster is sitting on OLM pad A, OLM A, right? They have like a fold out structure that looks like a fold out table that's on an SPMT. I stood up this close to it, and I looked at the SPMT. The SPMT is up to basically my torso. They are huge. How tall are you? I'm 6'4". 193 centimeters for anybody that's wondering. That speaks metric. That's tall? Did you see Flame Trench, dude? Here. If you haven't seen the last Flame Trench on NSF, you should watch this. It's me, Das, and Jack. Here. It's me, Das, and Jack sitting on a pickup bed with the launch pads in the background. See, note that Das and Jack are sitting on the tailgate. I am not sitting on the tailgate. I'm leaning up against it. And see what I mean? See what I'm talking about? Here, later I'm standing up. See? You prefer Jack standing on the bar? I thought Das was like 6'2". I don't know if Das ever stands up next to me in this. Did you put back that poor owner's manual? Yeah, yes, I did. Yes, it's back in the truck. The only person with a cup holder on their shirt. You're damn right. How did that look? I actually never. So stupid. I love it. At the end with the R. Hey, there's Roger and Gage, and Dan is over there too. Innovation. Meet innovation. Money. Topo Chico. Yes! Yes! He's Trunks. He's my son. Trunks. Anyway, sorry. Oh, yeah. Das went to get his coat for a second. Oh, back it up. Yeah, Das is tall. See? There you go. What was in that bottle you were drinking? It was water. Mineral water. Carbonated. Okay, just water. Sure, agua. Yeah, that was an awesome flame trench. We should do that more. That's awful, Baron. Don't ever link that in my chat ever again. Living the high life, I see. Yeah, anyway. Well, we got Starship out of the way. I thought you guys, would be more about like what's going on with relativity. There's also some Firefly news. Firefly is gonna fly Alpha again here real quick. If you want to look, Firefly is gonna fly Alpha on Flight 6 using an LM400 sat bus. There you go. We got another Alpha launch coming out of Vandenberg. This is the... Oh, dude, that freaking picture. Bro! Ah! Oh, that picture's so good, man. Yeah, there we go. Flight 6. It's a Victus mission, but I don't know what the name is. Going down for Flight 9? Yeah. You guys, look, all right, I looked at the numbers from the streams over the time that I was down there. You guys really like it when I go down there. I don't know why. Like, I would figure me being away from the stream would be detrimental, but it's clearly not. Like, people really like it when I go to Boca Chica, despite the ships blowing up. You know. The first Alpha launch will be from Wallops. Yeah. Mm-hmm. So, I mean, you're not away from the stream. You're taking it with you. Yeah. Nobody, Mead. I thought people would hate it. I thought people would be like, he's gone for 2 weeks. This is stupid. No. People are into it. So, yeah, people are into it. So, I guess we're going to keep doing it. That and NSF pays me to go down there. So, that's always good. And I get to stay in a hotel suite for nothing. The Margaritaville Hotel. South Padre Island. More cheesecake streams. Oh God. It's a pretty good gig, dude. Pretty good gig. Did you see that picture I just showed you? This is work. Watching that thing roll around.
Discovery.
Oh no. My job sucks. You know, like, oh no. Just look at that freaking thing. We know you only go there because of Stripes Tacos. How'd you know? It's not Stripes Tacos. It's a Laredo taco. Okay? Laredo taco in a Stripes. Okay? And they are freaking delicious. Their fajita burrito is fantastic. It's like, for gas station Tex-Mex, it's amazing. It has no right being that good, but I love it. It's like Bucky's brisket. It has no right being that good a brisket, but it's good brisket. Mm. More streams of repairing Jack's cars. I'll work on it. Hey, that actually reminds me. It's Jack's birthday. Happy birthday to Mr. Yak, Mr. Yak, Mr. Yak, 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 yak. Happy birthday to Mr. Yak. Sorry, you can't say happy birthday anymore. Get him on. All right. Hang on. Yo, what are you up to right now? We gotta wait for him to respond. Answer me! Are you too good for your home? Sorry. He's probably having a drink. That's... Yeah. Come on. Anyway. Yeah, he's hydrating, drinking water, clear liquid to hydrate for the hydrate. Just like that. The LRO just posted pictures of IM2 on its side. Uh-oh. Mott Scanley. Oh, no. No. Sorry. Bro, it's oh boy. Enhance. It landed in a crater. It landed in a freaking crater. Oh no. Bro. Dude, what did I tell you? I was saying, like, this thing must have landed on a tilted surface and then fell, like, down something to the bottom, right? Dude, it landed on the rim of the crater and fell in. I'm pretty sure. How can I tell? Well, look at the lunar terrain right there. You could see the blast marks from the regolith propagation. See, it's up on top of the crater. Dude, this thing landed on the rim of the crater and then fell in. Am I looking at that right? You see the blast mark right there? Oh no, it landed on the rim. It landed on the rim of the crater and fell in. Ah! It landed in the square hole. Dude, that is very much what that looks like. I mean, I don't know. We can't say for sure, but that the last for full resolution. All right. The TIFF is 295 megs. I'll just... Dude, it's in that crater. You can see it right there. Oh my god. Okay. Yeah, there it is. See that crater? Right at the mouse point. Dude, I'm that thing tipped into the crater. I'm pretty sure. I could be wrong, but bro, look at this picture. Interestingly enough, Blue Ghost almost did it too, right? Jam, that's taken from the Lunar Reconnaissance Orbiter, the LRO. Might have tipped over, but it's on the deck and transmitting data back. Yeah, unfortunately, the solar panels are in the dirt, Jam. That's what sucks. Yeah. Okay, so should we cap this off with relativity? So guys, relativity has been very quiet for a long time. Relativity Aerospace was a company that touted building like 3D printed rockets back in the day. Like they had a rocket that they basically had a welding bead, right? And they made a 3D printer with a welder that's just feeding rod, right? And on a spinning table, and made like 3D printed rockets. After Relativity launched their first Terran 1 mission, which failed, it didn't get past staging, they decided that they were going to pivot to building Terran R, which is a reusable rocket. Falcon 9 competitor, if you will. We haven't heard anything from them since. Anything. And Terran 1... Terran 1 launched in 2023. I had to look that up. It launched March of 2023, so 2 years ago. We have not heard a thing from them since then. How's the rover? Communicating but not deployable. Yep. Is this the Intuitive Machines picture? Dude, it is a really cool picture. Oh my gosh. That's awesome. I mean, it sucks that the thing... Dude, I'm telling you, this thing fell into a crater. Kerbal style. But that is a sweet picture of Earth. Camera exposure team 1. Yeah, unfortunately, none of the science experiments are good, but it's HR hazard relative navigation was supposed to avoid craters. Well, Rocket Guy, this picture kind of... Look. This picture looks like it was trying to land on the rim of the crater and fell in. Like, see all the blast marks right there? See all the divots? I don't know, man. Maybe it's just like some confirmational bias on my part. It looks like it fell into a crater. Didn't one of its engines refuse to cut off? Well, yeah, the computer wouldn't detect it as landed in this configuration because your legs aren't touching the ground. Somebody needs to go get that thing and turn it upright. Absolutely confirmational bias? Yeah, I know. Be quiet, network. Don't tell me what to do. No, you're probably right. No, I did watch the cast. It did tip over. I mean, that could have been anything, dude. It could have been the legs breaking again, like what happened on the first try. It could have tried to land in the crater and tip over. They could have had a problem with their engine not shutting off. There's a lot of different things, dude. I want to believe that it fell into a crater because that's hilarious. That is the most Kerbal thing I've ever seen. Question, could in the near future they could a starship bring them back? Maybe? Who knows? Anyway, Relativity is having some weird... We haven't heard anything. They've been basically silent for 2 years now. And, well, today we kind of figured out why. Eric Schmidt takes over as CEO of Relativity Space per an internal meeting. His first chief executive position since 2011 when handing control back to Google founders. Schmidt will make a large investment, taking controlling stake in the company. Interesting. I wonder why people don't read newspapers anymore. He bought his way in? Yeah, seemingly. So with that, we saw a huge update from Relativity. Right here. Terran R is coming to life. We've advanced design fidelity across all subsystems, hit significant hardware and software development milestones, and moved into first flight production. let's take a look at what the team has been up to. Flight build highlights. Both stage 2 barrels are built and stage 1 panel routing is underway. Nearly half of the panels required for first flight have been machined and formed. The thrust structure hub is built and undergoing integration. Stage 2 barrel assembly is underway with brackets being integrated. All 6 domes for Terran R's first flight are undergoing mechanical assembly. So this is a milled aluminum stir-welded ortho grid. This is not how Relativity made Terran 1. This is a more industry standard style of rocket. The company nearly folded. He kicked Tim Ellis out and gave him a board position with no voting capability. It's a hostile takeover. Ooh. Yeah, they completely ditched 3D printing after Terran 1, Shaw. Yeah. This is billet aluminum that's been stir welded together. That's much more in line within the industry. Interestingly enough. Yeah, there's the domes. I'd like to add that this is the old C-17 production line right here. See this building? That's the C-17 production. Note the hangar door. Yeah. A lot of people don't know that. Relativity is out of Long Beach, California, at the old McDonnell Douglas. The old McDonnell Douglas plant. Right there. See that big building? That's that building. See the doors? Same doors, baby. Yeah, this is the old C-17 production line, believe it or not. That's where they're building these rockets. I don't know. I thought that was a cool bit of fact. How do I know that that's the C-17 production line? Hold on. Well, if we could 3D buildings this thing correctly, it would say home of the C-17 on the side. Anybody from Long Beach knows that that's what that said. But yeah, see? C-17s. Lots of them. It could just be a gigantic cardboard cutout. No. Well, thank you, Dino. I'll read that off stream. See, now it's relativities. You can tell it's relativities because of the way that it is. And that's pretty neat. So that's a big production facility for what it's worth. Let's see what else. Any other pictures here? Propulsion has been keeping it hot. Our flight intent engine has accumulated more than 2,500 seconds of runtime, far exceeding its reusable service life. Recent upgrades include integrated avionics with flight-like software stack for closed-loop thrust, throttle and valve commands, and thrust vector control for gimbaled engine testing. With testing of our flight intent engine design well underway, we're near the end of Aeon R development and approaching qualification. Oh! Hey, baby. Oh, that's smooth. Damn. Wow. Yeah, to qualify that, to qualify your thrust vector control, you basically do the wiggles. You just move the engine around. That measures both axes of movement. That's pretty good, man. Pretty good. This is their test stand at Stennis. Avionics, flight software, and GNC are hitting key development milestones. Completed multiple iterations of advanced flight simulations from liftoff to landing to orbit. Developed algorithms for engine control, mid-flight guidance, day of launch trajectory design. Oh. In navigation, reached orbit with vehicle software and a hardware out-of-the-loop HOODLE test with flight-like GNC algorithms. Working toward vehicle hardware in the loop build. Critical test and launch infrastructure is rapidly progressing. At Stennis, Mississippi, activated dual bay test capabilities, allowing 2 engines to be fired back to back. Double the blue fire, double the fun. Cape Canaveral, Florida, laying the foundation, installing piles, and pouring concrete for our new Terran R launch pad and supporting facilities. Long Beach, California, developing new test assets, including a structural stand for qualification and acceptance testing. Oh, that's some beef, dude. Look at that thing. All right. Pictures of LC, what is this, LC-16? Whoa. Damn. That's Terran 1's pad right there. Terran R's pad is over here, and it's quite, that's a lot of concrete. They're building a flame trench. Interesting. This is LC-16 at Missile Row, dudes. So here, let me, He said the thing! So that's up here. LC-16 is that one. It's one of these. 1, 2, 3, or 4. Let me get the yeah, that one right there. There we go. So this picture was taken when they were still building the Terran 1 pad. See it right there? It looks like they're building the Terran R pad right next to it. You should see if you can host a flame trench in a flame trench one day. It's a good idea. The reverb would suck though. So that picture is taken basically from the same angle right here. Let's see if we can line it up. Okay, so there's the culvert right there. Like that. That's a big difference. Yeah, big difference. Cool. It's wild how close the firing rooms used to be to the launch pad. I love it, dude. Okay, I could see where you use New Glenn, but would Relativity have a market for Terran R? If SpaceX pivots to only Starship, they might have part of the medium market. Yeah, possible. So it looks like they're building a bigger HIF over here. They've already poured the heavier subgrade concrete here that's designed to hold up something heavy, and they're clearly already grading up to here and building a trench. It seems to be just a bigger version of that right there, which is interesting because that's the Terran 1 pad is a highly modified Titan missile pad, which is kind of cool. Or Titan rocket, it's not a missile. It was a Titan II pad back in the day, which is pretty cool. But yeah, that clearly hasn't been used in a minute. And you can see the old pad deluge drainage retention pond here. That's original Cape architecture from like the 60s, which is cool. Do you think Neutron would be a solid competitor? Yeah, possible. Yeah. Oh, what do we have over here? Water. Sound suppression. Oh, sound suppression pipes. See, there they are. They go underground. They go over there. Interesting. Cool. Anything else? That's their twin cell test stand right there. That's cool. And then the full Terranar update video here. And don't worry, I have the full video right here. Let's take a look.
2025 is going to be an exciting year because we have the full definition of the vehicle. We're moving on. We will have qualification engines in Stennis going through testing. That's going to qualify our flight design and unlock the ability to go produce flight engines at rate.
It
We'll
might
have
be
the primary structure
Mill.
completed for parts of our rocket. We'll begin integrating on what's often called the secondary assemblies, avionics, fluids, propulsion systems. We will see the entire factory, every single work center become alive. We will see hardware flow from one work center.
You will
to
see
the
boxes.
other. We'll lean on our digital systems, our enterprise systems.
Yes, Knight, I am.
The first year, we're going to have a fully functioning factory for Terranar.
And on the manufacturing side, the manufacturing teams have been hard at work, getting this production
Volume.
facility
I gotta be careful
operational.
about it
And
muting
also,
the
in
VOD
addition
on the
to that,
YouTube
there's a
side
lot
of things,
infrastructure
dude.
That's being put in to turn on our machine
It's the
shop
background
at higher
music from these
capacity to
videos that
produce more
mutes
hardware.
VODs.
Not only are we building out each work center, we're building out the capability of each work center and the capacity analysis of how these work centers optimize for themselves and flow into each and every other work center. This is a foundational
That's right, it
element of
goes in the
mature
square
production
hole.
system. The entire process starts with raw material arriving on the dock. We then mill out the panels ourselves, removing mass where we can to both optimize for strength and optimize for
Yeah, they're
mass.
gonna put them through a
We go
break.
through a rolling process where we take these panels and bring them as close to cylindrical geometry as we can. It doesn't have to be perfect because the friction stir welders that we've designed have the ability through the tooling and through different clamping methods to bring approximately cylindrical barrel sections into the correct tolerances where then we can proceed through the friction stir welding operation. We start vertical, we make one barrel. Then, as we have barrels stacked
That is
up,
only
we
a
can
section
go
of the
through a
42-minute
differential
update.
welding process where we complete a much longer cylinder than we would be able to complete with a pure vertical welding method. From there,
This is all industry standard, guys. This is how Vulcan is made. This is how Falcon is made. SLS is made this way. New Glenn is made this way.
we're able to add the end caps for domes also through a friction stir welding process, and that completes the tank for the primary structure. But a lot of the way this is built for our panels, the way we have to incorporate our design features, the weld parameters that matter for the alloys that we're using, this is all customization that is not available off the shelf. 2026 is bringing it all together.
Yeah, it is.
All elements of the vehicle.
The second half of a development campaign, essentially between the critical design review that we just passed in December and first flight, is one of my favorite parts of the entire industry. Some of the things that I look forward to the most are completing our primary structures testing. These are some of the most complicated tests we'll ever run, with millions of pounds on the rocket at dozens of PSI of pressure, really pushing the limits of what structures can do. We'll learn a lot from those before we go to stage testing. Stage testing, in my mind, is really where the rubber hits the road for the program. It's the first time that every piece of the program is united together across hardware, software, avionics, propulsion, structures, mechanisms, and the infrastructure teams. So that's really, in a sense, a dress rehearsal before our launch, where we can see the entire system and all of our teams come together. And I think that's personally my favorite part. And then from there, there's nothing like getting into a launch campaign getting the whole system together, and again, uniting the teams.
It's
the
awesome.
focus that you have in that final phase of the program is a feeling that
Should have
I
kept flying
always
it.
look to find in my career, and I'm really excited to get there this time.
The first steps after our first launch have already begun. We're already working on the second flight worth of hardware in some cases. Over 2025 and 2026, we'll have multiple ship sets of Terranar hardware in development so that we can follow up our first launch as quickly as possible with a second launch, third flight, fourth flight, and beyond.
Looking ahead to our long-term ramp rate, you know, you realize that manufacturing and scaling of
Oh,
hardware.
hello. No, that's nice. Damn. That's some pretty nice hardware there. Very good.
Production is only half of the equation. The other half of the equation really is tied to how rapid or reusable this vehicle is.
Reusability is one of the top goals of Terranar, even in the early days. From the very first sketches of Terranar that I did with a few folks, we've always been focused on getting to first flight fast, but making sure the architecture is extremely sound to make the vehicle reusable as fast as possible.
What do you mean,
One of the
tenacious?
fundamental requirements of any reusable booster system is the capability to complete entry, descent, and landing, which in the industry we call EDL. And there are three main things any system
Ray,
needs
what's up,
to do
dude?
to get there. First, it has to slow down from an extremely high velocity after the end of the first stage burn per ascent, somewhere around 4,000 or 5,000 miles an hour. It then needs to survive the physical environment of entering the atmosphere and slowing down from that high speed, which creates extreme levels of heating, thus temperature and vibration on every
I was gonna say, Ten, what are you talking about,
it
man?
needs to slow down and accurately hit the landing location, which in our case is a barge floating in the Atlantic Ocean.
The vehicle architecture is set up in a way where it's got reusability in mind right out of the gate. There are a lot of ways that this manifests. I think the first one in my mind as a rocket engineer is vehicle performance. We allocate a lot of rocket performance towards recoverability and reusability. I think the other area is that our designs out of the gate are kind of implementing those features right away. You know, our grid fins, for example, are there right away. Our landing legs are right away. And we're already thinking about how this vehicle operationally is going to perform for recoverability.
Because the vision for Terranar has always involved reusability, we've invested a lot of resources in understanding reusability and developing the booster architecture to allow reuse in the early days. One of the areas that is really essential to entry, descent, landing success is aerodynamics. So we completed a full test campaign for both the aft end of the rocket, which is a very sensitive area.
Ooh. Ooh. Look, if you guys remember, we were talking aerodynamics a little bit earlier. Stagnation points. There they are. See? You get stagnation in here. See it? And then you get your bow shock. See how the air compresses up against the rocket and it forces the air out of the way to the sides? Pretty cool, huh? What if the tip of the rocket rotates? I'm not sure what that problem is trying to solve, Combox, but
in terms of loads and heating, as well as tests to
That was
understand
cool.
our grid fin control system years in advance of our first flight. So our approach to realizing the full
There you go,
potential of
Kiki.
Terranar involves a block upgrade strategy. This essentially means that we'll stage different changes of the vehicle.
It doesn't
and
cut the
ground
air.
systems
It's
over
compressing
time
air.
to finally get to the full potential later on. And this is critical to the overall success of Terranar because it allows for learning in the early phases of the program while we can still serve customers without requiring us to get every single thing perfect.
The vehicle iteration is a really important part of our development path. Our development path doesn't stop at the Block 1 vehicle. We're already thinking about Block 2 and Block 3 and beyond and what that vehicle looks like. But you have to be very, very careful when you're looking at these upgrade paths, because if you make your first block too ambitious, too high performing, you're less likely to field it in a reasonable amount of time. What we've chosen here to do is just make the targets just a little bit easier on our team and shoot for, let's say, 20 metric tons to low Earth orbit for our Block 1 vehicle, and aiming to work through our reusability and recovery plans in our operations and our testing for the first block.
In Block 1, our goals are very simple. We need to get our customers to orbit safely, and we need to recover boosters. And the focus there is really on making Relativity into a new launch company in the market and starting to learn.
See what I mean? It's the C-17 production lines. C-17s would roll up and down through these bays right here.
Learn about reusability and operations to get ready for future parts of the program.
We're going to try to soft land the first stage for the first mission in the ocean. I think coming out of the Block 1 campaign, we'll want to have recovered and fully inspected and potentially retested a first stage that we've recovered, but we're really not leaning on true reusability for the first block of the vehicle. The first block of the vehicle I really view as more of a engineering stepping stone to get to the full reusability of the first stage.
Block 2 builds upon the lessons we learned in Block 1, specifically around collecting flight data for Ascent to expand our mission capabilities.
It is quiet because I don't
different
want the
parts of
background
customer
music to
marketplace,
mute the
and
YouTube
also
VOD for us.
to
Sorry.
Move into reuse, not just entry to.
I don't have a better way of
landing
doing
our
this.
booster stage. So that's really a place where we go from learning to execution and beginning to refine the system overall. From Block 2, we know that there's still potential in our architecture to fly higher performing missions and expand our mission set, and we'll get into that in Block 3.
No, Jackie, it will
Similarly,
not have a
as we
fully
get
cladded
into
tower.
reusability, not just entry, descent, and landing in Block 2, we'll take those lessons to get to
Can
the
you enable
highest cadence
captions?
possible.
Oh
for the
yeah,
overall
that's a good
system
idea.
in Block 3, where we're talking about 50 or even 100 flights a year. Even though Block 1 might start with relatively humble goals looking at the overall industry of getting to orbit and getting to reusability, the vehicle architecture has been developed in a way where the full potential will allow us to do things that no one has ever done.
That's right, Home Planet. Yeah, Relativity bought the plant from McDonnell Douglas. That's pretty cool. Neat.
Oh, this is space. I'm in space.
Serious Banana Bot, you're trapped in here with me. I'm not trapped in here with you. You're trapped in here with me, dude. Interesting. Interesting. So, yeah, it looks like Relativity's kind of reinventing themselves, which is pretty neat. And it looks like
Discovery, go at throttle up.
Tim Ellis did not make the right decisions for the company, and he got hostile taken over by a Google CEO, which kind of sucks, but what are you gonna do? Hey, Blue Adder, 37-month resub. Thank you. Don't you want to watch the full 42-minute video? You do like to entertain, right? Do they have the whole video in one shot? Where is it? What led up to the hostile takeover? No money. Relativity pivoted from their 3D printed design because the 3D printed designs didn't work very well. 3D printing your tank structure was not ideal. They did get it to work. For Terran 1, though, it worked okay. It flew, which is pretty cool. Hey, Zing, what's up, man? Relativity funding and promises were compared to snake oil. Yeah. It worked for a smaller rocket, but not for Terran R. Yep. Oh, Terran R program update. I see it. I see people going around labeling things scams left and right nowadays. No, I think it was a viable business venture. They just proved that it didn't work, and I don't think Tim Ellis could do the pivot good enough. All right, here's the whole video. It's 42 minutes long. I think we can watch till about here, because we just watched that part right there. Let's see what we got. It's this freaking music that's gonna get you.
Hello everyone, I am excited today to show you the progress that we've been making on the Terran R rocket. and the overall Terranar program. We have been heads down. We've gone from initial designs through critical design reviews. We're building a lot of hardware. We're excited to share that with you today. We've really transitioned from development into building actual flight hardware now, and we're going to show you examples of that, from the primary structure, the thrust structure, the barrels, the domes of the rocket, the avionics that control the rocket, the avionics boxes, harnessing, the software that we write in-house to control the rocket during its flight, fluid systems, COPVs, and then the testing
nice
systems
bottles
that we use both for the rocket and for engines, our launch site at LC-16. In addition to the primary rocket itself, we're also making outstanding progress on the flight intent engines, testing them daily in Stennis. We're also thinking about scaling of the rocket and developing our supply chain, developing our production capabilities, our transportation capabilities to move this large vehicle across the country. And so with that, we see all of the pieces of Terranar coming together. So there's no doubt about it, we have a long way to go, but I do believe that we have all the foundational elements necessary to succeed. We have an outstanding dedicated team. We have solid financial footing. We have flight hardware.
You hear that last part? Solid financial footing. Yeah, that's what happens when an ex-Google CEO starts investing in your company.
It's coming together, flight software that's coming together. We have the infrastructure necessary to build the first and then many more rockets, from our factory here in Long Beach to our test center in Stennis, Mississippi, to our launch site at Cape Canaveral. So
hey, Rocket Guy, real quick. You just said that, for example, the DoD alone throws away over 200 payloads a year because there aren't enough flight opportunities at a good enough cost. Do you think a fully reusable SSTO smallsat launcher could be viable in that type of market? What type of payloads are we talking about here? Asking for a friend. Usually 20 kilograms to maybe 375 kilogram Rocket Lab style. Which friend? Wouldn't you like to know, weather boy? Wouldn't you like to know? X-37 is busy, bro. No, it's not. It just came home. No, it's not. No, it's not. I would. That's why I asked. No, well, don't worry about it.
2025 is the year in which we build the first Terranar rocket, but we're not just focused on that first flight. We are developing the supply chain, the manufacturing tools, the testing and launch.
The hell? That's an awfully wide diameter milling head right there. Holy crap. Why such a wide tool? I'm gonna have to ask my dad about that one. That's a really weird cutting head. Why? What? That can't be an end mill. What the hell are you using to do that? You see, the wide diameter is really throwing me off. Usually when you get a milled isogrid like this, you're using an end mill, like a carbide end mill, which is Material removal rate, insert cutter. It's an end mill? Yeah. Well, it depends on the tool. It depends on what the tool's made out of, weather guy. Is that not the radius of the corners? Yeah, that's true.
Manufacturing tools, the testing.
I've just never seen it done like that. It's usually done with a smaller diameter end mill.
So now I'm going to hand it over to
calipers.
The great leaders here at Relativity to share the great progress that they've been making. I hope that you're proud of what you see. I know.
Yeah, Mutter, right?
We've only been working on this launch vehicle for about 1.5 years. And within the 1.5 years that we've been working with this small team, we
can go faster without breaking the tool. All right, Chad.
Conceptual design review from a clean sheet. We've gone through preliminary design review, and now we're in the middle of critical design reviews, which is kind of our finalization of the designs and full design review.
Hold on.
We've only been working on this launch vehicle for about 1.5 years. And within the 1.5 years that we've been working with this small team, we've really gotten this vehicle through conceptual design review. From a clean sheet, we've gone through preliminary design review, and now we're in the middle of critical design reviews, which is kind of our finalization of The designs and the engineering.
I just
drawings are
noticed that
getting
the
released.
PDR has a
Today, the
tapered
primary
has a
structure is
taper
all
in it to
designed
an
out.
upper
It's
stage,
all
but the
being
CDR did
manufactured
not.
and in work. The vehicle
Interesting.
overall doesn't mean the whole vehicle is designed, but we're about 50% of the way through critical design reviews. That's actually the vast
There's the
majority
stir
of
welder.
committed mass of the vehicle. The remaining work that we have
Got
is
some
mostly
Clico action
secondary
there.
structures and commercial off-the-shelf hardware.
The past few months of the Terran R program have been the most exciting to date. We have a huge
There's your
amount
mill.
of flight hardware that is now being produced, and we're going to show you. We have domes that are being processed and prepared to be installed into the barrels.
Oh, that's
We
killer,
have
dude.
barrel sections
Look
that are
at
being
this.
welded up
What a
from
treat.
formed sheet metal.
And then we have circumferential stir welding being stood up in short order.
Flight intent engines are being produced in-house from printing through machining, assembly. COPVs have arrived on site and are undergoing processing and testing.
Bottles.
We have fluid systems, the assembly of our piping systems throughout the rocket that has begun.
We also have a lot of the tank barrels being welded day by day, and the stringers, the stiffeners are being welded.
The thrust structure is being assembled from its component parts as we speak. Great progress is being made there.
So the first
Yeah, see, it
vehicle's really
tapers.
coming
See that?
together. Let's go over some of the architecture
Interesting.
from the aft end to the fairing.
Imagine if Terran R had a low taper
Going
rocket.
throttle up.
The first stage, on the very aft end, you'll see 13 engines. They're LOX methane, and their gas generator cycle as well. Our liftoff sea level thrust is
13?
269,000 pounds per engine. The first stage engine nozzle ratio is 25:1. Vacuum thrust will be 323,000 pounds. Our main chamber pressure is around 2,500 psia. Mixture ratio is about 2.78.
In building Aeon R, we draw heavily from the additive heritage of the Aeon 1 engine.
Pressure is around 25.
Open cycle. Dude, interesting. Open cycle, 2 turbo shafts. It looks like Raceway's not tapering. But can you imagine if Relativity had a low taper rocket? Indexable end mill with carbide inserts. Will? Yeah, okay. Interesting turbine design. And look, the upper stage engine is closed cycle.
500 psia.
Can you define open cycle? The gas generator dumps overboard out the side of the rocket. That's an open cycle. This is a closed cycle.
Mixture ratio is about 2.78.
In building Aeon R, we draw heavily from the additive heritage of the Aeon 1 engine program that we used on the Terran 1 rocket. The vast majority of
Oh, they're still doing that. I know what they are. I know they're thrust vector control mounts. That's what these tabs are. Those big, thick boy tabs that are like this thick. That's cool, man.
Aeon R is built of 3D printed parts that we manufacture in-house.
You know, we're leveraging that experience and really scaling the Aeon 1 engine from the Terran 1 program up to a much higher thrust capacity.
Merlin Vacuum is closed cycle, dude. It's
4 of them
regeneratively.
will be fixed, and also you'll see 4 landing legs in their engine from the Terran 1 program up to a much higher thrust capacity. 9 out of the 13 engines are going to be gimbaled. 4 of them will be fixed, and also you'll see four landing legs in their engine. 1 engine from the Terran 1 program up to a much higher thrust capacity. 9 out of the 13
Okay. That's a lot of moving parts, dude.
engines are going to be gimbaled. 4 of them will be fixed, and also you'll see 4 landing legs in their engine fairings. And the landing legs themselves, you'll see 4 of them with a sliding track for the upper strut. As you go further up the rocket, you'll see the methane tank on the bottom for the first stage, and then you'll see a liquid oxygen tank and 4 non-deployable grid fins. So both tanks on the first stage and the second stage, all the tanks actually, are going to be made of 2195 aluminum. But for the first stage, we're going to be using 2196 stringers, welded stringers, Z-stringers actually, welded Z-stringers for stiffening.
Yep.
For the first stage, we found that welded stiffeners were the most mass-efficient way to achieve the required buckling we needed for that tank. The downside to welded stiffeners, though, is that it adds a lot more welding and hardware into the tanks. On the second stage, we can avoid that by having the integrated orthogrid structure milled directly out of the flat aluminum panels that we get. And then the interstage will be an aluminum interstage, and the second stage will have a single vacuum engine that's also a gas generator cycle, and the fairing will be a carbon composite fairing.
In its reusable configuration, Terran R will be capable of carrying 23.5 metric tons to low Earth orbit, and future upgrades will allow us to carry even more mass to orbit.
We're not interested in only making and developing a singular boutique rocket. The thing that really drives us is making a commercially viable product that can be produced. And I think that's a big part of the reason why we're willing and able to make the pivots that we are making on the manufacturing side.
At Relativity, we use a hybrid manufacturing approach, where we use the best of additive manufacturing and traditional manufacturing. This allows us to quickly iterate during development while also scaling quickly to meet our customers' needs. The development of a rocket always requires compromises, and there's a trade-off between cost, performance, and timelines. We are actively performing that trade across the vehicle to develop the optimal rocket over time.
Ultimately, we're trying to find a sweet spot between something that's very affordable, can deliver a lot of payload to orbit, and can also be fielded in a reasonable amount of time with a high cadence as well. So there are a lot of factors that we look at, not just a single thing. We'll get more in depth into some of these trade-offs later in the video. Going back to the vehicle overview, the pressurant system will be helium. There are many trade-offs when considering what pressurization architecture you're going to develop for your vehicle. And for us, we opted for helium, and we're going to store that helium with COPVs inside the cryogenic propellant.
Yeah,
tanks.
that's par for the course.
Helium bottles inside the liquid oxygen tank for the first stage, but on our second stage, we're actually storing them inside the methane tank.
Terran R uses a combination of saturated and subcooled propellants. This gives us the best blend of performance and
Why would you do that?
needs. Moving up the vehicle towards interstage, you'll see 4 perimeter tension latches, but we're going to be pushing through the center. So we're going to have a center pusher that is going to be guiding the second stage nozzle through out of the interstage during stage separation. A lot of the magic for entry, descent, and landing happen after stage separation for the first stage. After the first stage separates, we use cold gas thrusters to flip the vehicle over and orient it for its entry burn. But while we're doing that, we're also being very careful about not letting the propellant migrate too far forward into the propellant tanks, mixing with the ullage. Once that's ready to go, we turn the engines on to slow the vehicle down, preparing it to enter the atmosphere. And the reason why we do this is we don't want it to burn up in the atmosphere because the heating environments are very high.
Supersonic retro propulsion!
We use the grid fins and the vehicle body aero to slow the vehicle down in conjunction with its thermal protection system. It enters its landing burn configuration where we look to deploy the landing legs and also finally slow the vehicle down to its final descent onto a barge. During aerodynamic re-entry, we'll rely heavily on our in-house developed thermal protection system. We're leveraging material science in that area to give us the lightest weight, highest performing material we can get while still meeting the...
Okay, guys, see that? Interesting. Interesting.
requirements of rapid reusability. There's a lot of proprietary work that's going into that material development.
Yeah, Bazdon, this is a pretty good video. There's a lot of good stuff, a lot of good info in this video, to be honest with you.
But it's an area that I'm quite proud of as well. The other area that's going quite well is a lot of our in-house.
They're talking about thermal protection systems. My guess is that that's a TPS for the interstage. Interestingly enough. But I could be wrong. It could be an engine section too. It's hard to say.
There's a lot of proprietary work that's going into that material development, but it's an area that I'm quite proud of as well. The other area that's going quite well is a lot of our in-house kind of homebrew GNC algorithms, software, and codes. We have a very strong GNC team here that has both a mixture of experience both in and outside the industry. The GNC team has developed algorithms for engine control, mid-flight guidance, and day-of-launch trajectory designs. Recently, our Terran flight software teams reached orbit with our Boodle test, and now
So hardware out of the loop, meaning it's just a simulation running. Hardware in the loop, meaning it's controlling something. They also have on-day launch trajectory optimization, meaning, so what's the point of that? Here, let me just make sure I heard that.
The GNC team has developed algorithms for engine control, mid-flight guidance, and day-of-launch trajectory design.
Day of launch trajectory designs, guys, is basically being able to have on-demand service to launch anywhere, anytime, in any orbit, to put anywhere, anytime, and go into any orbit. That is a huge, it's very interesting that they mentioned that. That is a huge thing that the Department of Defense is looking for. To have rapid response capability to near-peer adversarial threats on orbit, being able to launch anywhere, anytime. That's the same type of capability that Astra was trying to go for back in the day.
Recently, our Terran flight software teams reached orbit with our Boodle test, and now HITL is also underway.
We're making tremendous amount of progress on our ascent, reentry, and landing algorithms. Utilizing the Terran 1 guidance, navigation, and control heritage allows us to develop the algorithms necessary for Terran R much more quickly and efficiently.
The other area that I'm really proud of for the team is just how many of our mechanisms and valves we design in-house and test. So for example,
valves.
Our thrust vector control, our engine throttle valves, a lot of the solenoid valves. These are things that our team is really doing a bang-up job of designing and manufacturing and testing ourselves.
There's a huge buzz about the factory.
Yes,
Every day
them
new
too,
flight
Josh.
Hardware is beginning to be produced. Flight software is being released. Test and launch infrastructure is being built, and we're making great progress towards launch.
This is a great video, dudes.
Essentially means all the steps you take from the idea of a product to actually putting it in the market for your customers. If you look at the approach we're taking for Terran R's product development versus some of our competitors, I'd like to break it down by 3 or 4 different categories of the approach. One is the
Bazdon, it's cool. We haven't seen convergent design yet.
Another one is how much analysis or simulation that a team will do to predict things before they actually will experience them. And the
of course,
one,
rocket science.
how much
Cryo valves
content
is a pain in the
the
butt, isn't it? Freaking valves, man. They
as
suck.
you get further into the life cycle of the product.
The traditional approach
No,
to product
Denny, I don't think so.
aerospace is extremely serial. You'd have a whole design and development flow that results in a qualification design that you take through a qualification campaign, and only at that point would you really kick off full flight production. You do a lot of acceptance testing and testing at component level.
Space shuttle
You
engines?
minimize the risk to your stage campaign, but you also push those things out because you need to get through all of these component level qualification and acceptance tests before you're willing to go to stage test.
If you look at a lot of the very risky startups that are out there in the launch industry, a lot of them aren't doing a lot of testing at smaller levels of assembly. They're trying just to get to the launch pad or to a stage test, and they're also...
Who's doing that? I'm pretty sure no one's doing that. What? Maybe Astra, maybe, but they're not doing that. They tried to do that and it didn't work. The only people that did that is Relativity. Baron, you were thinking the same thing, right? I was like, what are you talking about, dude? That's you. That's you guys. You guys are the ones that did that.
Startups that are out there in the launch industry, a lot of them aren't doing a lot of testing at smaller levels of assembly. They're trying just to get to the launch pad or to its stage
Homie,
test.
that's you!
They're also not reusable. So in that sort of environment, it's very hard to learn as you go. There may be a lot of surprises that you find because individual high-risk items weren't studied in advance or tested in advance, and that can lead to a pretty tough
You sure about that?
or even the
Are you sure about that?
early in a mission. And we've seen that in the industry time and time again. So when we look at the Terran R approach, we're trying to optimize between those two.
Oh, hello.
Small scale where it's less expensive, but still pull the learning from working at the full scale ahead as fast as we can.
So what that means for us is that because we need to start building flight parts before we've completed all of our qualification, We may need to include some adjustability or optionality in the design that actually gets released.
Okay. I'm not trying to dump on relativity. This is a very smart way of doing this. Everyone does this. There's a reason why it's a really smart way of doing it, because that's kind of industry standard. Is that bad? Like, at least everybody should. Yeah. Yeah, I suppose that's a good way to put it. Like, I'm not trying to be a dick. Like, that's a good way of doing that, because that's the way to do that.
We also try to leverage acceptance testing at the system level where we think that's appropriate. We may not ATP every single component before we go to an engine test or a stage test if a component failure during that higher level test is not going to be catastrophic. We believe that full-scale testing at the stage level, or as high a level of integration as you can, is really the best way to learn about your design. We're focused on...
Didn't the guy just say that they're doing the opposite of that?
Trying to accelerate to those huge proof points as fast as possible. We really depend on the experience of our leadership and our senior engineering team to know what are the smart risks to take versus what are the things that we really need.
Seriously, the guy just said other people in the industry don't test their small components. We test all of our small components. And then the next dude in this one said they do the opposite of that. Like, he said, well, we test components at a higher level. Well, I think they said in the middle that they're trying a mix. Okay. I was like,
to get right up front.
Not trying to be mean, like,
not a one-size-fits-all answer.
Ooh, swirl.
We really need to tailor our approach to each subsystem based on the criticality, the
there you go.
How much you need to test, etc.
There you go. There it is. You're right, Josh.
More amenable to analysis, and you really don't have time to iterate it. So you've got to get that right the first time. That goes through a more rigorous and
oh my gosh. It's a thrust structure, Josh. Yeah. Did you just add more engines to the outside? You just crudely pasted 4 engines on the outside of the design. Like, you just crudely pasted your face over mine. Why do you want to listen to the stereo while the television's playing? Because I like to party? Wait, why am I talking to you? I hate you. Oh, come on, man. We were doing really good there. All right, man. I'll talk to you tomorrow.
Analysis and qualification approach than something like, say, an avionics box that you do have a chance to iterate if you need to. We do test those things at the component level, but the design cycle is much shorter, so we may not spend as much time in analysis.
Yep.
And then the engine obviously has a high dependence on test. There's things that we can only learn on the test stand, and it's going to have to be an iterative design. So in the engine team, we really focus on getting things out to test quickly rather than spending our time in analysis, learning on the test stand, and iterating the design that way.
Having a manufacturing strategy that's aligned with our need to develop the product quickly and get to the right risk level for our customers, that's really the name of the game. In areas where we know we need to iterate to learn, we use manufacturing processes that are really nimble. And the main area for that is our propulsion system, using a combination of powder bed fusion and WAM technology and then some other tech.
Oh, that's sexy, man. Dude. They're still using, look at that. They're still using the original printing techniques that the Terran 1 used for A&R. Oh, that is smaxy. Damn, look at that thing. Oh, that's actually super cool. I really, really like that. That's really neat. Yeah, that's the case with a lot of different rockets, Black. But yeah. Yeah, ribbed. Yeah, that's right. Alec, yeah, that's right. It's ribbed.
Manufacturing processes that are really nimble. And the main area for that is our propulsion system. Using a combination of powder bed fusion.
Powder bed fusion. So, that's cool. That's cool, man. So basically, this thing is sitting in like aluminum powder, and they shoot a laser at it. And the laser sinters the powder into a solid shape, And it just, the laser just keeps going back and forth and back and forth and back and forth, and that's what you get. Yeah, laser centered. Super cool. At least if I'm understanding this right, that's what that looks like. That's super cool.
And wham.
They showed it early. Oh yeah, there you go. Yeah, that's your laser centerer. There it was.
Strategy that's aligned with our need to develop the product quickly and get to the right risk level for our customers. That's really the name of the game. In areas where
that is badass, dude.
We need to iterate to learn. We use manufacturing
Dude.
that are really nimble, and the main area for that is our propulsion system. Using a combination of powder bed fusion and wham technology, and then some other techniques that we might be the first in the world to use, we are able to learn really quickly on our test stands, and also through design and analysis, make changes, get back to the test stand, and get closer to that really end goal product. And then similarly, when it comes to things that are very long lead items where we don't have the opportunity to iterate as much like primary structure, we use techniques where we know the reliability is very high. Traditional methods that you might see on other rockets, we use those too, and then we put our own special spin on it.
We're optimizing for the things that matter to our business. Speed of getting the product out the door and getting customers on board, payload to orbit, and reusability, which unlocks the economics that we really need for long-term success. That means that when we're assessing technologies, we're not necessarily looking at what's the most advanced thing out there. We're looking at the things that meet those needs. How do we get a reusable vehicle out there quickly so we can start flying customers?
Across the Terran program, every single decision, every single engine.
Look at that thrust chamber assembly,
focused on what we call
or combustion chamber assembly behind him.
Which are performance to orbit, development time, and the cost of.
Oh, that's badass, dude. That's actually super cool.
Try to make it very clear that even if one system is not hitting its own perfect targets, if we're delivering that target for our customer at the end of the day, then we're still being successful.
You can't just focus on speed to first launch, though. The long-term key to this program is really reusability and payload performance to orbit. We do have to find the right key drivers within the design for getting to reusability quickly, and the key drivers for performance. And those things are going to require more attention and more upfront investment than things that are still required to fly,
Nice
but
home
maybe
planet.
less critical to the long-term success of the program.
So when we look at the balance of getting to a first launch and serving our very first customer in the launch business at Relativity versus developing a reusable high-cadence vehicle for the future, the approach that I recommend is to try and make them the same thing. There may be some cases where we make it...
Have you tried just, you know, if you want to do task A and task B, have you tried just doing task A and task B? What?
Decision on a small part of the first rocket that isn't
wait a minute.
to fly 50 times a year. But by learning on that first one, we will go faster to the second or third iteration of that part or system to actually hit the high cadence. My job really overall is to find those opportunities to pull the learning ahead and then make the goal the same, even though we have different outcomes in different parts of the program.
So I think one of the most misunderstood things about Relativity has been and why were we 3D printing barrel sections on a rocket with Terran 1? So when I started the company 9 years ago, we knew that additive manufacturing was really only able to build about a cubic foot in scale. So I thought with a bunch of smart people and a bunch of time, we could really push the boundaries of what that technology was capable of. And we did just that. We built a rocket that was 85% 3D printed, launched it to space. We proved the viability of our additive manufacturing tech.
Coming off of the Terran 1 program where the primary tanks were wire arc additive manufactured, we reviewed that decision again and for the Terran R program. And coming out of that trade, we felt that for the Terran R program, right now and right today, friction stir welded aluminum alloy tanks are the best choice for us right now. And so at Relativity Space, we're not afraid of changing and pivoting where we need to meet our development goals. And our development goal, to be really clear, is to field a very commercially viable, high-performing vehicle. And so we're not dogmatic about how anything should be made or the history of the company or anything like that. We're just dogmatic about fielding a great product.
Our manufacturing methods are a trade like anything else on the vehicle, and it's really important to understand the pros, cons, and risks of every trade And so when we look at a manufacturing method that could be as impactful as how we're making the barrels or the domes or the fairings, this really comes down to a balanced approach between engineering, supply chain, manufacturing, and the global business. Smart decision making is optimizing for the entire business, not just focusing energy in one particular area that we may optimize locally.
The latest tool at the time that's going to be the best choice for manufacturing is what we're going to use. And we initially set out to try to print the domes. We quite frankly struggled to get that process at rate high enough to really kind of fit the...
Why the heck are you printing it sideways?
Commercial needs of this vehicle. So from there we pivoted to more traditional aluminum lithium alloy domes, and we're partnering with a supplier to help us develop them.
So the domes that we're buying are some of the most advanced that have ever been produced. I have personally seen domes produced 4 different ways for different launch vehicles, and this is one of the most performant production methods I have ever seen. And this outside vendor being really good partners with us. They want to scale with us.
Ariane Space. Yeah. Okay.
Want to invest in our business. They want to share their learning, and they want to help Terranar succeed. This is where we had to make a smart decision for our business and truly a smart decision for our customers' business.
Any successful development program that I've ever been a part of or ever seen really didn't have a perfectly straight and narrow path right to developing that great product. And I think what defines kind of the success of companies and programs isn't necessarily how many great choices the company made out of the gate. It's really the agility and ability of the staff and the team to pivot as quickly as possible and still drive progress, and quite frankly, not be fazed by change. Sometimes development is running down the wrong path as quickly as possible to then pull yourself out of that path as quickly as possible to get on the right path.
We have gotten farther in 3D printing because we invested in those domes, and we're using that 3D printing technology elsewhere.
We're still using additive manufacturing on Terranar in areas where it really helps us. You know, things we're looking at are areas that help us get to market faster, develop, build, and test faster. WAM has been a big part of our engine program since the onset.
Sick, dude.
We use WAM to clad our outer jacket for pressure capabilities on the main combustion chamber.
I think we're seeing some tension between how we would optimize Terranar from an engineering perspective, from a technology perspective, and how we would optimize it from a business perspective. It's not uncommon that a company such as ourselves needs to strike a balance between those things. When we think about the long-term trajectory of Terranar, much technology development will occur. Many insourcing decisions will occur.
This guy related to NASA spaceflight, or am I tripping? The guy on the video or me? Haxa-chan. Me or the dude? Which one, dude? You. Yeah. I just got back from Starbase because I hosted the NSF cast down there, amongst other things. Yeah, I'm EJ. I stream on Twitch. I always say that. Well, you found the Twitch stream. There you go. We're reading about relativity space, or watching relativity space right now. There's a video. I'm the NSF guy. I'm the guy. Yeah, Haxa-chan, that's me. NSF. You made it now. That's pretty cool. I am him. He is me. NASA Twitch stream started. Yeah, Meat Snacks, because the Sphere X and Punch launch is in an hour. At the end of this relativity video, we're actually going to skip the path to first flight and beyond reuse. We already watched that. I want to see what they have to say about propulsion. Vandy weather is trending to worse. 90% no-go. Update 95% no-go.
Those are not necessarily the right trade for the business today.
How did Titan react coming back from Texas? Oh, great. He was very happy to see me. But yeah, Haxa-chan, I'm EJ. So my NSF is like my side hustle, dude. Believe it or not. This is right here. This is my main source of income. I stream on Twitch and I teach people about space and we play games. Right now, you're watching the EJ's Space and Rocket Review. You two girls, you in the hat, tell your friends, Space and Rocket Review. This is my own... The NSF analog would be Raptor Side Chat. Uh-oh. What was that noise? Hold on. Trailer's being weird. No, breathe. The Sphere X and Punch launches tonight, and then there's a Starlink right after that. Hold on. Huh. Huh. Why no updates from Blue Origin? Well, I don't know. We'll see. Yeah, successfully connected to network. That means the perimeter cameras at trailer reset. Let me just check something real quick. Oh, they did it on purpose. Yeah, they reset it. Okay, cool. All right, I was just making sure. Because you heard it successfully connected to network. That's the perimeter camera making that noise. That means the perimeter cameras weren't on. Now they are, though. Tim Ellis was the 3D printing guy for Blue Origin. Yeah, Home Planet, that's right. Terran 1 was all about a fresh, unique approach, and now Terran R seems to be about as conventional as physically possible. Dude, I don't know, man. Outsourcing your dome design is not... That's a little... Relativity intended for Aeon R to be stage combustion, and the first stage to have 7 engines, but when they started development, they found themselves stuck with making them work, so they switched to a gas generator cycle. Yeah, okay. Starlink is now 12:14 a.m. Got it.
The manufacturing processes are on the front lines of that tension, of those decisions we have to make between what technology do we want to push ourselves and where do we need to compromise, perhaps, to advance the business goals.
And I think the fairing falls into that category. It's a very large structure, and also the separation mechanics and the multi-body dynamics of having the fairing separate cleanly, getting the fairing qualified, also the fairing acoustic performance, in addition to
not for the Sphere X launch. It's out of Vandenberg, David. The Starlink, maybe.
And quite frankly, I feel very fortunate to have a partner that can help us build our first fairings.
And so for our business, it's really
Those are Ariane 6 fairings, by the way.
question of, do we want to spend our resources and our time that way? And is it right for the customer trade?
Both
Does it
coasts,
matter for
methane.
Their objectives.
Cape
that we
initially,
build our
though.
own fairing, or can we start
Actually,
delivering
just
on our
Cape right now.
customer demands faster by partnering with a company who can provide us some of the experience and production capability on a fairing system?
The COPVs were a similar trade-off. It would be more beneficial to the program right now for sake of execution speed to partner with a vendor to get our COPVs off the ground. Every decision, both technical and non-technical, we have our customers in mind. We're developing this vehicle to be a commercial workhorse that can really help support and deploy customer, customer constellations or satellites, and for their own businesses.
AON-R is a GG cycle LOX LNG or LOX methane engine. Produces about 270,000 pounds of thrust at sea level. We have 13 AON-R engines on our first stage, and we have a single vacuum variant on our second stage that produces about 323,000 pounds of thrust.
What it does is we feed fuel and oxygen in a fuel-rich mixture ratio to the gas generator, which is then ignited by gaseous hydrogen and gaseous oxygen, which jump starts the gas generator ignition. That provides exhaust gas that is fuel-rich to the turbine wheels that spins the pump. That, however, is not enough to jump-start the engine, so we supplement that force with high-pressure nitrogen.
Can I just...
Is a GG cycle LOX LNG or LOX methane engine. Produces about 270,000 pounds of thrust at sea level. We have 13 AON-R engines on our first stage, and we have a single vacuum variant on our second stage that produces about 323,000 pounds of thrust.
What it does is we feed fuel and oxygen in a fuel-rich mixture ratio to the gas generator, which is then ignited by gaseous hydrogen and gaseous oxygen, which jump starts the gas generator ignition. That provides exhaust gas that is fuel-rich to the turbine wheels that spins the pump. That, however, is not enough to jump-start the engine, so we...
Is it hydrogen or is it LNG? I'm confused. I mean, the gas generator spinning turbines like that, that's pretty garden variety stuff, believe it or not.
Supplement that force with
LNG.
high-pressure nitrogen, which blows into
Discovery,
the turbine
go at
wheel,
throttle up.
the turbine exhaust, and starts the engine. That gas generator then spins the pumps, which pulls propellant from the
that's
vehicle,
how it works.
liquid
He just
oxygen,
said
and liquid
gaseous
natural
hydrogen
gas
and oxygen,
into the
which is...
combustion chambers for the engine and provides thrust.
Terran program leverages densified propellant, or propellant that's cooled below its saturation temperature at ambient pressure. This is really important to the capability of the vehicle because it allows us to get more propellant mass in the same size tank, and it also provides us better thermal margin to saturation or cavitation when we're operating the engine.
You have two different variants of AON-R on Terran-R. You have the Stage 1 engine, which is designed to operate at sea level for the most amount of thrust
Discovery,
at the most
go at
critical
throttle up.
time, which is liftoff. Then you have an upper stage engine, which is AON-R vacuum, which is designed to operate in the vacuum of space. AON-R Stage 1, AON-R vacuum look very similar. There is one major difference between them, and that is
I'll link up the video.
AON-R leverages a lot of the learning that we gained from AON-1. It's the same cycle gas generator and uses the same propellants, LOX and LNG. But AON-R is a much larger engine with much higher thrust and also requires us to have throttle and MR control in order to meet the mission of the Terran-R vehicle. So we structured the entire AON-R program around several iterations, and that also informed our choice of manufacturing technologies. By leveraging additive, we're able to quickly make changes to key components like the combustion chamber, the injector, the pump, learn from tests, deploy a new design, rinse and repeat. We use powder bed fusion or PBF printing for a lot of our complicated fluid components. We also use the wire arc additive manufacturing, or WAM technology that we developed from Terran 1 for cladding and feature buildup on our combustion chamber. Overall, we have 4 main iterations of the AON-R engine. The first was ultimately a manufacturing demonstrator and a chance for us to go and try to build this much larger, more complex hardware. We called that AR 1.1. The second iteration, AR 1.2, is what we tested in late 2023. This was able to hit the state point of the engine, hit the thrust and MR that we were trying to hit, but it was not a flight-like package and it wasn't capable of gimbaling. We had a number of engine failures in AR 1.2 that really gave us the key learning that we needed to build a more robust, high-performance product in AR 1.3 and beyond. We were able to meet our MDC milestone with the AR 1.2 iteration, which was the first one that we got.
I understand, W.
I think that's really a testament to the quality and experience of the team, as well as the key choices that we made on engine cycle and propellants in order to leverage our previous learning.
The very first time you start testing a rocket engine, you should expect failure. Part of the process for developing an engine is ensuring that your block upgrades as you go through the development process include that expectation of failure. If you know your first engine is going to fail, which it will, you focus on the developmental areas that are the hardest to obtain. startup, shutdown, throttling.
Yep.
Don't combine all of the additional pieces that you can learn on a bench somewhere else.
One of the key advantages of the GG cycle is that you can get really high quality data from component testing of your TCA and your gas generator. And that set a foundation for us
Thrust
to stretch
chamber,
even higher and push
thrust
for
chamber
higher
assembly.
performance. AR 1.3, which we've been testing in late 2024 into 2025, is really a flight-like engine design. It fits the vehicle package, it's capable of gimbaling, it has our full-size engine.
Hey, Deadbringer.
So we're now hitting
60
our
months, you got your worm logo, dude.
it has
Oh,
features
hello.
the vehicle needs as well, including pressure and heat exchangers.
Woo!
Maybe most importantly, AR
Very
1.3
nice.
also included flight-like avionics and a flight intent software stack. This is the first chance for the Terranar program to really demonstrate this full end-to-end capability.
Dovikin, what's up,
We
dude?
use
Long
an
time no
engine
see.
controller that controls the startup and shutdown sequence, as well as closes the loop on throttle for vehicle throttle control. We're getting all of our last little changes in. We're dialing in the operating point that we're going to use to qualify the engine. And then we're going to roll that all
Right
into
home
an
planet,
AR
right.
iteration, which will qualify and we intend to fly.
Where a dev campaign paints where the engine operates, the qual paints where the engine should run in flight and establish that life expectancy. If you know the total life expectancy of an engine is 2 tests for acceptance testing and stennis, and then 1 static fire prior to launch, and then a total stage 1 ascent, and then a relight, and then a landing burn. You take all of those starts and all of those run times, and you build them together into your program. And your qual program basically says this engine can operate under those specific conditions as many times as we need it to. AONR is designed for reuse in mind from the beginning, so our intention is from very early flights to be able to recover stage 1. What that essentially means that the engine has to relight in space on its way down. What that requires is a very simple approach in the design to ensure that complexity does not add failure mode. A hydrogen-oxygen ignition system for the gas generator and a spin start is a very stable, simple approach to relighting an engine. That simplistic approach is usually the best for ensuring reusability and reliability, which is probably one of the most important components of stage 1 that function on relight.
Any difference between the way you test your engine and the way you operate them in flight is an opportunity for an issue or a failure mode that you didn't see in test to crop up and keep your vehicle from working on the day that matters. This means that we need to really understand how the engine is operated on the vehicle, what its environment is going to be on the vehicle, and then investing in our test capabilities to make sure that we can do exactly the same thing on the ground. We have both the engine team, the test team, as well as our mission reliability team constantly looking, what are the test like you fly deviations? What are we not anticipating? How can we eliminate those before we get the stage test? We think this is really going to help us move faster through stage testing and have a more successful launch.
There's an industry
Sphere X and
term
punch scrub,
called
guys.
Test like you fly, which I've always thought is a little backwards. It actually should be you fly like you tested. When you test the rocket, you're bounding what you know the rocket is capable of doing reliably. I know the rocket will light at this temperature. I know the rocket will fly at this pressure. I'm confident the systems work there. And then you should baseline what you think the flight profile will stress the rocket to, and then test to a larger window than that to ensure that you're not doing anything for the first time when you release the rocket for flight.
Yeah, that guy knows what's good, dude. He's probably played Kerbal before. That was cool. We've already seen the last end of that video. I watched it at the beginning of this, ironically. That's a really cool video. If you guys want to watch it, I'll link it over in YouTube. And I'll link it in Twitch as well. Yeah, that was pretty cool. I have trepidations about horizontally integrating your company like that with the domage and the fairing and everything. And then some clear propulsion changes. But pretty dang cool. Pretty dang cool. Yeah, that was pretty cool. And I'm happy that Relativity isn't on life support anymore, dude. Because I was getting worried, man. Eric Berger had a pretty scathing article about them a little while ago. You know, but who knows? I wonder if they didn't have the bandwidth for full vertical integration. I think they pivoted too much because they figured out that their dome structure couldn't be scaled. They said it. They all but said it in that dang video. But here's my thing about that, dude. And this is, I suppose this is an easy question to ask in hindsight, right? But here's what I'm thinking. Like, okay, you're not scalable. Why stop flying Terran 1? Terran 1 had customers. Why stop flying that? Continue with Terran 1 if the printing is working correctly, right? And then once you're revenue positive, or at least pushing, then go into Terran R production. I just don't understand why they didn't do that. Probably couldn't do both. Well, Tim Ellis lost his company because they chose to do one and not the other. Interestingly enough. Yeah, they had a contract with Telesat. Your rocket, like, they were talking about their rocket doing all this damn work, right? Terran 1, they had customers for Terran 1, and they chose not to do that. What? All right, whatever. Wait a minute. Wait a minute. Hold on 1 second. Hold on 1 second. Hold on 1 second. Hang on 1 second. Trying to call Jack. He didn't answer. Oh. Hey, what's up, man? You're on the stream. Happy birthday. Do you love it? Mr. Yak? I know we can't hear him. I know we
Can you
can't
hear me?
Yeah. Oh God. Ah. Yes. Yes.
Can they hear me? They can hear me, but you can't? What's going on?
No, I can hear you. No, I can hear you. I can hear you. I can hear you.
Yay.
Leica
has her head on my lap and she's looking at my phone like, where's EJ?
Oh, Locals.
Are you there?
Yeah, I can hear you. I can hear you.
Okay, cool. Yeah, no, Leica very clearly can hear your voice and is looking for you. It's kind of breaking my heart a little bit.
Oh, now I feel bad.
No, you're good, dude. Thank you for the happy birthday wishes.
Yes. Stream is also saying in both chats on YouTube and Twitch, they are all saying very happy birthday. And then somebody just made Jack emojis just fly up across the screen.
Discovery.
Wait, what, on YouTube?
Oh yeah, I stream on YouTube too. Don't you know that?
I did not. I mean, with us, yeah. I didn't know you had your own YouTube channel.
Oh, we've been making moves here at the JSA, man.
Ooh, I like moves.
Anyway, you having a good birthday, dude?
Yeah, you know, we had some of the Starbase contingent over last night.
Cool.
We all Dan grilled some steaks, some big sweetie. I made mashed potatoes, which I love making mashed potatoes. I'm autistic about it. Sorry. And yeah, everyone came, and like we were just like sort of sitting around eating. And then I put on. Have you ever watched Victor Charlie Romeo? Or sorry, Charlie Victor Romeo?
No.
It's a movie. And it's Charlie Victor Romeo, cockpit voice recorder. It's basically like a very like low budget isn't the right word. It's like minimal production value. It's like
So a B movie.
a stage with a crude cockpit set, and they go through several different air disasters, just like sort of it's only cockpit voice recorder transcripts. So it's like it's just I don't know. It's amazing. It's amazing. It's on I think it's on Netflix. I don't know. Either way, we watched that, which is like the most jack-coded thing ever. We ate steaks and watched air disasters, so it was good.
The most jack-coded thing ever. I love it, dude. I love it. That's awesome.
Yeah, it's a good time. And then, and like halfway through, someone's like, "Wait, aren't Dan and Ryan flying tomorrow?"
Whoops.
Oh shit. No, honestly, part of the reason I put it on is because I could tell Ryan would vibe with it, which he did. Dan seemed like he was vibing, but he also might have just been low key terrified because he knew he was flying tomorrow. But also they use the same actors like over and over again for the different vignettes in the movie. And so at one point we were joking like, man, if we get on a plane and you see that guy behind the pilot's seat, like, do not get on that plane. And I drove him to the airport today, and I'm driving back to the house, and like 30 minutes later he texts me. He's like, dude, I see the guy in the cockpit. I was like, nice knowing you, but actually not really. That's a lie.
Okay. All right. Yes.
Anyway.
This is what hanging on with Jack is like, chat. Yes.
This is actually remarkably accurate. Hi, chat. Thank you for the birthday wishes. Dude, thank you again for coming out and getting shit done.
Hey, no problem, dude. It's all good. Yeah, Sphere X just scrubbed.
Wow, again?
Yeah, weather's no go. The Vanden
More
fog.
More like Scrub X, am I right? Honestly, no, I'm like, yes, because I'm media credentialed for Sphere X. I was going to be there for that, and then Starship happened. So if it scrubs enough, I will be there for it. So I'm happy.
That's right. It goes in the square hole.
It goes in the Vandenberg hole. All right, dude. I'm gonna go back to watching YouTube videos and eating ramen.
My guy. All right.
You know, we live a single bachelor life here. It's what we do.
Yeah.
We eat ramen and we watch YouTube videos.
Sounds
we
good,
drink
bro.
Modelo.
Drink Modelo. All right. Modelo Especial. In Topo Chico?
Sí.
All right, man. Chat says happy birthday. I say happy birthday. I'll talk to you later.
Hell yeah. Y'all are the best, man. Thank you again.
See you, buddy.
Bye.
If you guys don't know who Jack is, he is one of my co-workers over at NSF. He's a good dude. He hosts Flame Trench with me on Fridays. That's pretty funny. The real question is, why was Ryan still there? Jack takes good pictures. Yes. You don't know. Jack's awesome. He's a good buddy of mine. About relativity, they thought the switch from Terran 1 to Terran R would be swift, but their dome design didn't work. The entire 3D printing didn't work on a big scale. They didn't have the capability to build a big enough engine to support Terran R and ended up switching the design 180 degrees. Well, yeah, that's what I said, dude. You know, if you figured out that the problems don't work, fly the rocket that you have that's operational. Why would you switch away? Somebody's grinding that damn tower pretty hard. I just don't understand why you would do that, but hey, whatever. Bro, don't break it. Don't break it, homie. Jack's birthday is the 10th. It was today. I think I'm going to buy Jack a birthday present. I think the birthday present might be parts for his car. Yeah. Just ship him down there. That guy's going to town with that dang I don't even know, dude. That might be a torch, but it's spraying sparks like an angle grinder. Your birthday's on the 11th. Well, happy birthday, W. At least SpaceX and Rocket Lab picked up the contracts. Yeah. Another eBay turbo. Yes. 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 Anyway. All right, guys. Well, if Spherix and Punch scrubbed and Starlink pushed into tomorrow, I think we'll stop. Yeah, well, your birthday was 3 weeks ago. Well, happy birthday 3 weeks ago. Mine's Thursday. Lots of March birthdays. Oh, hey, congratulations. What's the #1 part to break on Land Rovers? Isn't it the alternator? No, it's the everything. Right? Am I right? High five. Anyway. So, I think, yeah, with the Starlink pushed, SphereX scrubbed. So, yeah, I think we'll stop here. Neon Heat, Jack, you've replaced your alternator 3 times? It's one of the things on your truck you learn to do yourself. Right on, man. Dude. I know, it's tomorrow at 12:15. Due to unfavorable weather... Hold on. Status update on the SphereX mission. Due to unfavorable weather at the launch site and an issue with one of the NASA spacecraft, we are standing down from tonight's Falcon 9 launch of the SphereX and Punch missions. Next launch opportunity is Tuesday at 8 p.m. Pacific. So that's 11 Eastern tomorrow. I can't believe Jack didn't know you had a YouTube channel. I guess, you know, he wouldn't know if I didn't tell him, but now I've told him. Bad time to have a spacecraft issue. Yeah, I would argue that it's a very good time to have a spacecraft issue. Because the weather was your violation criteria. So if you had a spacecraft issue and the weather was good, it could have potentially launched, which is not what you want, dude. You always plug Twitch. I do. Like I said, he wouldn't know if I didn't tell him. Man. Dude, we gotta put like a Ford alternator on that damn thing, dude. Put a freaking good alternator on there. Not even a Ford one, like a GM 1-wire, dude. How many amps is the dang alternator? We'll put like a 70 amp alternator on there, and then it'll be fine. Hopefully not a rollback issue on the spacecraft. Well, they scrubbed 24 hours, dude, so... Bosch. Yeah, there you go. Bosch gave me this jacket. Anyway. Wait. Jack, is Leica still there? Likey's! Hello! Yeah? Did that do anything? Push button start, snorkel, stainless steel rear door panel, rear door fix, brakes, forward sunroof. Then we can mess with the alternator. All right. All right. She perked up. Likey's! The dog's like, where's EJ? Where is he? You'd have fun with an amateur radio? Yeah. That's awesome, Baron. She loves you. What year's the Rover? Jack's got a 02 Land Rover Disco. A Disco 2. It's not a bad truck, guys. Like, I hate saying that. I want to just say, oh, should just have a Ford all the time. It's not a bad truck. It just has 300,000 miles on it. What do you want? You got 300K out of the damn thing. Like, that's pretty good for a Land Rover. Like, I'm sorry. That's pretty good. The thing should be in a junkyard with Fred Flintstone holes in the floor, yet it's not. Okay? It's not. Is the dog's name Leica? Yeah, Jack has a dog down there at Starbase, and the dog's name is Leica because she looks like Leica, the dog that the Soviet Union launched into space. Yep. It's a pretty awesome name. That's enough miles to be on the moon sideways and then some. That's what I'm saying, Jim. She gonna go to space. Oh. 300K on a disco says more about the owner being good than the manufacturer. She's gonna boil. What? 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 No. 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 She's gonna boil in 3 orbits. Yes. No. No. No, that's bad. You do not want this. Who's a good dog? Who's a good dog? Oh my goodness. All right. No, I do not advocate violence against animals. That is disgusting. Stop it. Especially dogs. Don't do that. Chat. Don't do that. Anyway. All right, dudes. We will, wait, where's that list that you gave? Push button start. Snorkel. Okay. Stainless rear door panel. Rear door fix. Brakes. Forward sunroof. All right. Send him a kilt with the car parts. All right, we'll do. Twitch chat is being bad. That's right. That's right. All right. Anyway, guys. Sphere X Punch scrubbed. It's 10:39. We've been going for exactly 10 hours straight. We should have used frogs. They wouldn't have realized they were getting boiled. All right, I'm leaving now. This is the part where I go to sleep. Okay? All right, dudes. I'll talk to you guys all tomorrow, noontime, same place. Workers and resources, more space news, Sphere X Punch tomorrow, hopefully, and update on that Starlink launch. The Starlink launch pushed in tomorrow. We'll see what happens. Okay, who are we rating? Yeah, let's check on the Twitch side of things. I haven't rated anybody in a long time. On YouTube, I will see you guys, but on Twitch, we're gonna go raid somebody. We're gonna go raid. Etal is playing Voices of the Void. What's that about? Let's go see what Talix is up to, dudes. I don't know what this game is. Anyway, I'm going to go check it out. On the YouTube side of things, I'll talk to you guys tomorrow. On the Twitch side of things, go pop through and raid Talix. He's a good streamer. He's a good buddy of mine. And I will talk to you guys all tomorrow. Thank you very much for watching. Happy birthday, Jack. And have a very good rest of your night. See you guys later. Thank you.